Hello folks, I'm hoping that this will work tonight because we've had an afternoon of the most incredible frustrations. I've had my computer lady over here trying to sort out two computers, this one and that one, working simultaneously, and it hasn't been easy. Something I notice as a characteristic of the computer industry as it stands at the moment is that there's a lot in instructions particularly that people within the industry will assume that the layman understands. Strings of IP addresses, meaningless 3- and 4-letter acronyms. Prime example. If you look down here, you'll see a thing called, what do they call it here? A Gigabyte Easy Smart Switch. It's supposed to allow, quite simply, two computers to work on a single Ethernet cable. And they say it's plug and play. But what happens when you plug and play it? Not much. Now let me give you a quick read of the instructions of what plug and play involves. 1. Find out the IP address of the switch. By default, the switch receives an IP address from a DHCP server, brackets, or a router that functions as a DHCP server, whatever the hell that is, in your network. You can find out this IP address on the DHCP server. Where do I find that? By the modem? Out in the street? In my computer? Under what window? Where? If the switch cannot receive an IP address from the DHCP server, it uses the static IP address of, and 9 figures follow, with a subnet mask, of 9 figures follows. And so it goes on through 6 subsequent steps, none of which has an acronym that I even vaguely understand. This is supposed to be plug and play. Funny thing, but I think plug and play means you plug it in and it works. More fool me. Anyway, it's 9:31 p.m. We're getting close to overdue for being on air, so I'll hit the air. Hello, this is VK3 Alpha Mike Lima, Chris in Burwood East with the regular Saturday night test transmission. This week dealing with digital transmission on HF, in which an Australian, David Rowe, VK5DGR, first licensed as a 14-year-old in the 1980s, and now the developer of what's known as Codec2 and FreeDV, has been very deeply into getting workable, narrowband digital speech transmission systems going for HF radio, and I would say with no exaggeration that that is where the future of HF radio lies, particularly for those of us living in metropolitan areas with high noise levels. And I'm very happy to say that David has given us permission to use his lectures tonight. But first of all, as a bit of a background to this, let's talk about CODECS. CODECS, they're at the heart of the problem of digital audio and speech, particularly transmission on HF radio. What's a codec? What's a modem? Well, Andy Walker and Sean Carruthers, in the early part of this century, about 2004 to 2006, used to produce a podcast called Lab Rats. Very informative, very explanatory, and they didn't let any acronyms go by without explaining exactly what they meant. So as an intro to this night's subject of digital audio in narrow bandwidth, particularly for HF transmission. Let's hear from Andy Walker and Sean Carruthers back in 2006.
Hello and welcome to another edition of Lab Rats. I'm your host, Andy Walker.
I'm your other host, Sean Carruthers.
And today on the show, we're going to take a look at something that's extremely complicated. I find a lot of people have trouble with it, and that is something called a codecs.
And that's something that might be affecting you watching this show.
That's right. If you're trying to watch us on our XVID version,
let me tell you,
we have a few problems with that. Anyway, We'll get into it in a second. So first, a message from our sponsor.
And the sponsor, whose output I'm not at liberty to send over ham radio, is advertising in this 2005 vintage podcast video display screens in 4:3 ratio. I haven't seen those for a while. 4:3 ratio video screens. Anyway, back to Andy Walker and Sean Carruthers.
Okay, Sean. So codecs. It's actually an acronym, isn't it? It's not an acronym. I guess it's a
mashup.
Really. A mashup of words. What does it mean?
So it's code decode, basically.
Right.
So when you have an audio or video file, you have a codec. It's basically something that tells you how to read the file. It encodes it in a certain way, and then it decodes it in a certain way, so that you actually can play it back. So,
right. Basically, it's a translator, isn't it?
It's a translator. Right. So you have to put that data on the disk, the hard disk, the videotape, however you're recording in some fashion, right. And the way it puts it on there is the encoding method.
Well, and a lot of it is also about when you're taking the raw bit and dumping it on a tape or whatever the storage medium is, because video is so demanding, audio is so demanding from a space perspective, that they want to compress it. And so that's the idea, is you're going to compress it down to something that stores really well, right? So that we're not all spending a fortune on hard drives and have to figure out a way to put 100 gigs on a DVD or whatever.
Right, and if you're looking at something like one of the new HD DVD formats, like either Blu-ray or HD DVD, there's audio formats in there, this codecs, that are lossless and they're uncompressed.
Okay, so lossless versus lossy. Let's talk a bit about what that is first. We'll get the lingo out of the way, and then we'll show you exactly how it all works.
So lossless is basically as it appears. So if I record bit 1, 2, 3, and 4, it comes 1, 2, 3, and 4. Mm-hmm. When it's lossy, it will take what the human ear can hear or the human eye can see, and when it comes to audio and video, and it will say, can I get rid of this? So it may be 1, 2, 4, or even 1, 4. So it may interpolate between the two. And interpolation is basically looking at two bits in that process and sort of guessing what's in between.
What the next one will be. Actually, MP3 is a classic example of a lossy compression, right?
Right.
Because what happens is MP3, they say it's near CD quality. Mm-hmm. The high end is completely erased because really the human ear doesn't hear a lot of that.
Right. I can't remember exactly what the ranges were for the human ear, but I think above 20,000 it really tapers off, and below a certain level, it really tapers off. So you can't really hear below that, and you can't really hear above. Psychologically, you might hear it a little bit, and that's something that vinyl purists get into. But in general, most of the people that are listening to it won't even notice that it's gone.
Right. So that range is actually cropped by the codec.
Right.
And so you use less space to store these things. That's why you can get about a minute of audio per meg of storage on an MP3 file, encoded about 128 kilobits per second.
Right, and that was the near CD quality that they were talking about. And of course, if you encode it at a higher bit rate, it'll go up as well. And that's including more of the information. It's less lossy.
Right. Now, where you're going to encounter problems with your codecs, perhaps, is when you tend not to have a problem with audio as a general rule, because most computers these days will come with an MP3 codec and those kinds of things. Mm-hmm. Where people run into problems is when they start to use a little, unusual video codecs. For example, we talked about our XVID version, which is, the file name is an AVI.
Right.
But AVI is not so much a file format, it is a wrapper to wraps around a compression format of some sort.
Right, so when you're getting, say, a DVD, you know that it's a DVD. You take it onto this other DVD player, and it should play no matter what it is.
So actually, the format is actually MPEG-2. That sort of
Right.
DV format or DVD format is MPEG-2, and that's the codec that you'll require for that.
Yeah.
But AVI is very different.
AVI is very different because it can encompass a number of different codecs underneath, so different methods of encoding the file underneath. So it may say AVI, but it may actually be something else in between, or inside the guts of that one. So I'll have one, you'll have a different one. They're completely different inside, and they're not compatible necessarily.
That's right, yeah, absolutely. So, so just from the interactive portion of the show today, I'm going to show you a couple of tools that you can use to kind of diagnose some of the codec problems you may be having on your machine. One of the most likely problem you're going to have if you put your hand up if you've had a codec problem, and if you look up and your hand's up right now, it probably means that at some point in time your machine hasn't been able to find an MPEG-2 codec. Because very frequently you reformat and reinstall your hard drive perhaps, or you get a new computer and it doesn't come with an MPEG-2 codec built in.
Right, and if you're actually watching the show right now and you have a codec problem with our show, put your hands up. You're probably talking about XVID. And we'll get into that in a little bit.
We'll talk about that towards the end of the show.
Yeah.
But so
it's a bit of a special case.
It is a special case. Yeah, it's like our special child. But let's talk a bit about MPEG-2 because I think that's the thing you're going to run into the most likely. And the solution is very simple. But first, I want to introduce you to a free tool that you can get from Microsoft, and we'll put this in the show notes. It's called the Windows XP Video Decoder Checkup utility. And essentially what this does is it goes into your system, when Windows does not have a natural place that lists all of the codecs that you have on your system. There's no kind of codec utility that sort of manages all this, unfortunately. There are a couple places, and they're in strange places that you can kind of look them up, but it's not all-encompassing, and really Windows needs that desperately, I think.
I'm not sure whether Apple has an all-in-one utility for the Mac, but I know there is a place you can go to look to find out what codecs you have on your system.
Oh,
a very special directory.
Oh, that's very good.
But we'll talk about that in a bit.
Okay. So very quickly, in the show notes, I'm going to put a link to this file. It's it's free downloadable from Microsoft.com. It's called Windows XP Video Decoder Checkup Utility. And essentially all it is it's an application you run, and it goes into the registry, and it looks for all the MPEG-2, the DVD codecs on your system. Now, if you don't have any, it's going to go, there's nothing here.
Can't play DVDs back.
More often than not, though, if you've installed, let's say, Nero, and you've installed maybe WinDVD and that sort of thing, you might actually have multiple MPEG-2 codecs, and some are better than others. So this utility is cool. Let me just show you real quick how to change it up. So as you can see here, all the MPEG-2 decoder or codecs are listed, and as you can see, there's a green check mark next to the one here. This is the Nero video decoder. I actually got a copy of Nero Ultra recently and installed that. But if I decide that Nero is not the codec that I want to use for MPEG-2 decompression...
What does the check mark mean? Does that mean the one...
That's the prime one. That's the default MPEG-2 codec the system is using.
So you can use the other ones if you manually choose them during a process where you have that option?
Absolutely, yeah. So you could actually go... for example, I'm going to go down here to the main concept. It's an Adobe codec. And I'm going to say set this one as preferred. And you might get a couple of error messages. But you can try them out. So go get yourself a DVD, put it into Windows Media Player, play it back, then use this utility, change up the MPEG, and you actually will see some quality differences. So it's worth actually experimenting with those kinds of things. You can actually set these things as a primary. I can restore the defaults here, of course, which is a nice little feature as well. So that's one of the things that you can do to diagnose any given problem. Now, it won't deal with problems like AVI problems, and we're talking about XVID in a minute.
Yeah, and the AVI and MPEG, though, there's a little bit of overlap there because some of the AVIs usually use MPEG inside, but there's also files that are tagged as MPEGs as well.
That's correct. Yeah, exactly.
And they're not the same thing, are they?
No, because AVI is a wrapper. So, for example, and one great example of this, you can have an AVI file, and inside can be the DivX codec, right? Which is it's a company called DivX Networks. So you can download. That's a free download from Divx.com. MPEG-2, and it could be inside an AVI. There's a whole bunch of different things that can be inside the AVI files. So if one AVI file works and the other one doesn't, it's because whatever's in the guts of that thing, you don't have the codec for it. Now there's a cool little utility to look at some of the codecs you have on your system. This is called A-Free Codec VT. It's a freeware program. There's no spyware in it, and there's no adware from what I can tell. They claim it's not, and I haven't. None of my alerts went off, so if you find some, let us know. And this has a really great thing because it has something called the Codec Library. And you click on this, and it will list every single file format out there that it knows about, and will tell you whether or not these are installed on your system.
So that's what was making.
This is VK3AML with a regular Saturday night session to talking about codecs, and we'll get into talking about compressed digital speech via HF radio shortly. But I could point out that the codecs in this presentation, 2005, you can multiply the number of them now by about 20. I mean, back in the 1990s, we were dealing with, if any of you are old enough to remember, the FLV files, flash video, further back, real audio, real video, the .RA files, XVID, and even for those who are really ancient with long white beards, OGG Vorbis. OGG Vorbis, who remembers those? Those now have largely become the codecs of yesterday. Things change quickly. So this presentation from 2005, maybe early 2006, is now historical. Back to the boys, Andy Walker, Sean Carruthers, Lab Rats.
Making that noise earlier.
Yeah, it's got this really annoying audio click, click, click thing. Every time you sort of change modes. Listen.
Oh my goodness.
Anyway, so other than that, it's actually quite a useful tool. So
I'll find out what codec that noise is encoded in and remove that from the system.
That's right, exactly. But here you go, here's a classic example. So the div2 file format, it's saying is the codec required to play that file format is DivX, and it's showing, see here it has a little disk there, it's showing that it's actually physically on the disk right now. If it doesn't, then it has a little query item here. I think is it a question mark or something like that? Hard to say.
That looks like a little magnifying glass.
Little magnifying glass, which is, I guess, go find it. So if you click on that, you can actually go and search either the A-Free Codec website.
So it'll tell you where to go.
Yeah, and that sort of thing. So it's a useful little tool. So if you're having a problem with a particular file format, then you can actually use this tool to figure out what's going on.
Can you use that to diagnose what codec a file uses if you can't play it on your system?
No, actually, what I would use for that, well, in fact, actually, the AVIs are the ones you can have problems with.
Right. A lot of times when I found a cool little AVI, people say, hey, man, look at this file. It's really fantastic. And you run it on the system, and it just goes, ERP. Windows Media Player will say, you know, I've tried to install the codec for this, but I've just given up.
Well, one of the favorite media freeware open source playback tools is something called Vlc Media Player, and I actually got installed a copy here. Again, we'll install a link to it on our show notes.
Yeah, and Vlc is actually the one that barfs out on our XVID feed. In fact.
Well, I'm going to show you an interesting little thing here. Let's go into let's open up LabRats1. Somebody emailed us recently and said, hey, LabRats1, the XVID is not working very well at all. So I'm going to open that up here. And
that sounds familiar.
There we go. I'll just put it on pause here for a second. Stop! Stop!
Hi, welcome to LabRats. This is
Stop.
Yeah. Yeah.
It's a little buggy at times. Anyway.
Okay. So
I'm going to go to View. I'm going to go Stream and Media Info here.
Okay.
And
for those who are finding this incomprehensible, perhaps if you go to the live stream, which has the video associated with this, which you'll find if you dial up VK3AML 23 July 2022. That is, Google the phrase VK3AML 23 July 2022, and you should find the videos that go with this. VK3 Alpha Mike Lima testing, and back to talking about codecs.
No, I can't do that. I have to play the file.
Yeah, just press the space bar. Okay. And just wait for it to kick in. One more time.
Pause.
There we go.
Hi, welcome to LabRats. This is
Okay. Well, anyway, we'll let it play. I'll turn that way. Let me turn the volume off. There we go.
That'll work.
All right.
And that's one of the things with codecs is if you've got a buggy codec on your system, it can do really wacky things to your playback as well.
Absolutely, that could actually be directly related to that. So you're going to click on. Let's go back to that menu again. So View, Stream and Media Info.
Right.
And we're going to go to the Advanced tag here, and we're going to actually look. It shows us the codecs, the XVID codec,
right.
And
what the resolution
frame rate,
is.
And here's the audio piece of the puzzle. Because of course, in a codec situation, you have two pieces of a puzzle. The one that does codec compression and decompression for audio, the audio piece of the thing, as well as a codec for video as well. So in this particular case, it seems to show that everything is normal. Now I did have a little application here that maybe it was the other one.
It looks normal. Let's put it that way.
It looks normal, yeah, exactly. But one of them, I did have a little application here a little earlier on, and maybe it was the other one, the A-free codec. Let me just boot it up again here and get that going. It was reporting that the XVID file was actually damaged. And it's entirely possible. I mean, so what's going on your end when you're actually doing that compression?
Okay, so when I'm putting together lab rats, I'm taking the master clips from the videotapes that we're recording onto, and that's going into DV format. That goes onto the computer. We render it out and send it out to, the first step we use is H264. So we use a master clip, and then I render that off into other formats.
Right, okay.
So that's called transcoding, where you take one format, turn it into another format.
Okay.
So I'm doing this all on a Mac anyway. Yeah. So for most of the formats we do, that's perfectly fine. Yeah. But I've got a codec for XVID, which is a little bit wacky. The XVID support on the Mac is a little bit dicey in terms of actual codecs. Now, I mentioned it works a little bit different on the Mac. You have a QuickTime library. You go into the main hard drive, the library directory, and then QuickTime, and then it's got a bunch of things marked blank dot component. And those would be the codecs that you're using. So you've got xvid.component or mpeg.component, that sort of thing, divx.component. The xvid component that I'm able to use for that is a little bit flaky. Let's put it that way. So if you're playing it back in xvid, it goes a little bit of the ways and the audio drops. And I do apologize for that. It's not something that I would love to do, but thankfully Frank has pointed us in a different direction that might actually be helpful.
Okay.
So
we might be able to resolve that.
Hopefully even when you're watching this episode, you might actually be able to watch us past 9 minutes.
Right. One of the things that, so while you were talking, I was pulling this thing up here, and it was A-free codec VT again, and what I did is I went in and I pulled up the file, one of the 20, actually episode 23 in the XVID version, and look what it says. It says his AVI file is possibly damaged.
It is possibly damaged.
So something is going on with that file. It hasn't compressed properly, or the codec has a bug in it perhaps, or something along those lines. And so that's when you guys are going to play it back and you're having a problem, this is what's going on. There's something wrong with that particular rendering of that file.
Hopefully not for much longer.
Not for much longer, though. We're going to fix it for you, we promise. A final word about codecs. So if, let's say, you're having trouble with DVD playback, because again, I'm going to go back to that because it's the most common thing. One of the things you can do is there is a couple of companies that will actually sell you DVD codec packs. One is called Cyberlink, and the other one is called Video. And these guys, basically the kit that they will sell you is downloadable from the websites. Yeah, it's called either $10 or $20, something along those lines.
For the longest time, I remember Video and Cyberlink. They had offered DVD player software for Windows-based machines, because in the early days when DVDs first came out, you couldn't actually run DVDs on these machines at all because there was no software. There was actually a hidden Microsoft DVD player in there that for some reason only popped up once you tried to install one of the other ones and it broke. You couldn't use it before that.
Right. Well, this is on an old version of Windows.
This is on old versions of Windows. Yeah. Now it seems to be bundled, so that's not as big a problem anymore. But yeah, both of those companies were big in the add-on
market. And so what tends to happen now, let's say you buy an IBM, you buy a Dell or something like that, it will ship with a free version or a light version of some of these DVD playback things. But even if you don't use that, if you remove it from the system, you generally don't want to do that, because the MPEG-2, the DVD codec in that application, is allowing you to play your DVDs back in either Windows Media Player or even Real Player, things like that. So if you run into a problem, you said, well, it used to work, I reinstalled and reformatted, it doesn't work anymore, where do I get my codec from? Go and install that light version of that DVD playback software that you got with your computer originally, and it'll come back. If you don't have that, can't find it, disk is broken, whatever, go to Video or Cyberlink. We'll put show notes again. We'll put the link in the show notes here, and you can download their DVD pack or MP3 and DVD pack for about $10 or $20, and it's a quick solution to solving those kinds of problems.
Yeah, and it costs a little bit of money because I think they have to pay somebody for the license to use that.
Yeah, there is
codec.
The patent for the MPEG-2 technology is shared by something like, I don't know if it's like a dozen or 2 dozen or 5 dozen companies. And so what happens is every time a little bit of money gets paid for that MPEG-2 codec, that money gets sliced and diced and it gets paid out to all of the patent holders.
Yeah, and that's why you almost never see DVD players for free.
That's right. Hey, and welcome to Lab Rats. I'm Andy Walker.
I'm Sean Carruthers.
And Andy Walker and Sean Carruthers now presenting a review of Skype when it was new, using, of course, a voice over internet protocol. And here they also touch on the early days of codecs.
And today on the show, we're going to talk about talking on the internet, making telephone calls across the internet. It's a technology called VoIP. Acronym boy, what is a VoIP?
Voice over Internet Protocol. And you actually capitalize the V, the I, and the P.
Why?
I don't know.
Voice
over is just not that important, I guess.
Right. And IP is Internet Protocol. I mean, this is sort of, this refers to the Internet. Things move across in information packets across the Internet, and so IP is what that is. IP addresses. Is it information packet? IP? TCP IP?
Internet Protocol.
Well, there you go. All right. Let's talk a little bit about voice over IP then. Sean, you brought a bunch of gadgets today.
Yes, and you brought the eggs.
I did, yeah. And sadly, I broke one. So I had to kind of duct tape it together. But
just be very careful with that one, because that one could let go at any time.
All right.
So voice over Internet Protocol is nothing new. It's actually been around for a few years, but up until recently, the Internet actually wasn't up to the speed of voice over Internet Protocol. You would try to do a conversation.
I'm going to fade that down there because I've got a frame freeze on my return stream for reasons I don't understand. I'll just refresh that. But I'll flip on to the next presentation. There may be a copyright problem, I don't know. But since trying to get, let me put this back on to, there we go. Since trying to get the switcher to work, we've had all sorts of strange things happen to our TCP IP address. It seems to have been reallocated 2 or 3 times. We've had to reset internet, and so tonight's stream is completely technically unpredictable because I'm not getting a return stream. I have an indication of the stream out on the OBS software, but no indication of what people are seeing and no indication of the number of people on the stream. So what can I say? Let's go on to the lecture by David Rowe, the first of the 2 lectures that he gave that I think are well worth seeing. David is an engineer in the IT field and was instrumental in developing what's known as Codec2. That's the codec, open source codec importantly, that became the basis of FreeDV on HF radio and a number of other ham radio-based codecs for digital audio transmission. And David is, hearing a talk from David is like getting it from the horse's mouth. The first of the 2 lectures I'm going to play for you was recorded at the Linux conference in 2016, the Linux conference. And in this, he is trying to sell the idea of two-way radio, digital two-way radio, to computer people. In the second of the talks that he gives, which is a little bit more recent, 2020, he shows recent developments in the codec, including a slightly broader banded version with far better audio quality. Now, I haven't been terribly interested by digital speech on HF FreeDV up to now because, to me, the audio quality of the initial incarnation of this was really awful. And those who are watching the stream will know that I take some care over the audio. But the new version of Codec2, the new versions, plural, are really most impressive, so I think this is well worth looking at. First presentation 2016 almost being historical, and the second presentation being more up to date. So here's David Rowe, VK5DGR, talking about the development of Codec2 to a Linux conference in Geelong in 2016.
Speak at Linux Conf, and I always really enjoy it, so thank you for the opportunity. I'd like to talk about open source two-way radio, something that I've been working on over the past year since I saw you last. First of all, we'll talk a little bit about what is two-way radio, some of the major components that are involved in processing two-way radio signals, open and closed issues as applied to radio. Where does open source come in and why does it matter? One of the core components of radios is the modems. It's something that I've been playing around with a lot for the last year, and I believe there's some big gains to be had using the right sort of modems in two-way radio. Then I'd like to have a little bit of a digression to hardware hacking and some of the things that have been ways people have been hacking radio hardware and some of my thoughts around that. I'd like to introduce the SM2000, which is a open source, open hardware, open software VHF radio project that I'm working on with several other people, and some of the applications for that particular platform, including a low-cost TDMA repeater. Okay, so this is what two-way radios look like. This is a simple little cheap $50 FM one. These are some DMR radios. Handheld, little antennas, speaker microphone, and push to talk. They also come in this sort of form factor, which some of you will be familiar with. Pay attention to your product. This sort of thing would go, I recently used one of these in a combine harvester. Farmers might use this sort of thing, as well as many other applications. Okay, so the worldwide market for two-way radios is around 50 million units per year. They typically use VHF and UHF spectrum, a little bit lower in frequency than, say, mobile phones or Wi-Fi. One of the key features is that they're low on infrastructure. You don't need a whole range of cell phone towers or even, indeed, electricity or anything to keep them going. Typically, they're used in point-to-point mode, so you'll talk between yourself and someone else, or via something called a repeater, which is a little bit like a single cell phone tower, sits on a hill somewhere in your city and will retransmit your signal to other people, given that you both have line of sight. Another key feature is two-way radios work when nothing else does. And that's why they're particularly popular with emergency services. If you're in the middle of a bushfire or there's an emergency or a flood, two-way radio will work when all the other lights are out. Typical ranges are tens of kilometres. Mainly for voice, a little bit of data going on, but mainly for voice. They're connectionless. You don't make a phone call. It doesn't ring in general when you make a two-way radio contact. You press the button and start talking. And often it's a one-to-many situation. So when you talk, there might be half a dozen other people listening and you can reach them all at once. Applications, personal communication, police, emergency services, construction, the farming example. Some farmers will have one in every vehicle. Mining, ham radio, quite popular there. And LCA, if you look around, some of the organisers here will have two-way radios in order to communicate with each other. Two-way radio is shifting from analogue to digital, like everything else. There's some interesting things about the digital versus analogue contrast, in particular compared to other services. This is an older style radio that uses analogue FM, and that still works pretty well, and they're still fairly popular. The digital has some advantages. In particular, one thing people are aiming at is spectral efficiency. You can get several digital signals in the space of one analogue signal. Some potential advantages in connectivity. Once the signal's digitised, you can trunk it, route it, send it over the internet, record it more easily. However, there are some lingering issues with the current generation of digital systems. Voice quality. Many of them just don't sound as good as the FM. They struggle with some voices. That's partially to people like me to blame with speech codecs, but that's just sort of how it is. So, some arguably not quite as good as some of the analogue systems they're replacing. There are several competing closed systems that seem to be iterating quite quickly, being rolled out and withdrawn or modified. And there's people playing the closed source lockdown game, using closed source components in the protocols, speech codecs, in order to make them proprietary and difficult to, I guess, innovate in and do the sort of things we like to do in the open source community. This is a picture of the plot of an analogue and a digital signal side by side. The middle picture, or the middle signal, that's the spectrum of an analogue FM signal, and to the side, for comparison, that's the digital one. And that gets they're similar sorts of quality signals, similar sorts of audio bandwidths, but the RF bandwidth over the spectrum is a lot wider for the FM one that you can see. That gives you a bit of a feel for how you could fit several digital channels into one analogue channel and get better spectral efficiency. That's important if there's a lot of people trying to use the surface. There's only so much spectrum, so we want to use it as effectively as possible. Some of the major components. The codec takes the speech from the microphone and compresses it down to a low bit rate. That's a key component in getting spectral efficiency. Compress it down as low as you can, and the RF bandwidth that you use will be as small as possible. Then there's the protocol that wraps up the codec bits in an appropriate form for that channel and that mission that the radio is doing. Then the modem that takes the ones and noughts and works out the best way to squirt that over the RF channel, converting it into an analog signal that travels over the signal. There's also the radio hardware. I've intentionally drawn that as a small box because the way things are going, the hardware is becoming a smaller and smaller part of the whole system. It's all becoming software. And indeed, right down to all the effort, where the effort and development work is going, it's all turning into software. Even when you're building radio hardware, most of your work is firmware on that, not the actual silicon. Open and closed as applied to radios. My simple rule, if it's open, it's good. If it's closed, it's bad. The codec is closed in all the current commercial digital radio systems. That's causing a major frustration to everyone, from manufacturers to people like, say, in our community or the ham radio community that like to experiment. If you're a manufacturer, it locks you into another commercial company. You have to keep paying them money. That's no fun. Also, it means difficulties for innovation. Also, it adds to your bill of materials. You've got to keep adding, for this piece of software, you've got to keep adding $5, $10, whatever they're charging you for this codec continuously. So that could be a large proportion of what it costs. If this is a $50 or $100 radio and you're paying $10, $20 in license fees, and all your other software is open source and free, that can be a major frustration. For experimenters, of course, we like to change things. So being locked out by EULA and being explicitly forbidden to modify the codec code on pain of being sued, that's a major frustration as well. Protocols tend to be standardised. You can get the standards, download them and implement themselves if you want to. Same with the modems. The modem implementation is generally up to you, and differences in performance can be obtained by good or bad modem implementations. The radio hardware is kind of a difficult area to get into due to the expertise required to work on it. Also, the issues with standards. So you need to make sure your radio emits only the signals it's meant to at the power levels it's meant to, so you don't interfere with other services. However, that's getting easier. Radio hardware test equipment to develop yourself is getting available, the right chips are coming out, and a lot of the radio hardware is migrating into software, which means that you don't have to depend so much on the radio silicon as that we used to. Okay, I started looking into, I guess, modems for two-way radios about a year ago and doing some simulations, and found out they have a few problems. So this is my motivation. I found these big performance gaps that I think I can fill, I can improve things, so I have to fix it. I don't really have any more solid motivation than that sort of open source, scratch that itch ethic. I've got experience with my own speech codecs, so that part's covered. I know how to build modems. I'll wing it with the protocol, or work with some other guys that can do it, and just see where it takes me. So this is real open source experimental stuff. I don't really have an end game or a big commercial product in mind or anything like that. So, the modem. What does a modem do? The bits go in, ones and noughts from your protocol layer, and then they get, the idea of the modem is to send it over the analog channel to some sort of waveform. The channel adds noise and various other impairments and tries to corrupt your bits when they come out. Basically, if it's a really good modem and a really good channel, the same bits that come out are the ones that went in, but usually we get some errors in some of the bits that are sent. Now, a good modem will do a lot better job with a given signal in a noisy environment than a bad modem will. And the way we measure that is with something called a bit error rate. And that's given, say you send 100 bits, if one bit's in error on average, that's a bit error rate of 1%. A really good modem might do a better job over a given channel and get a lower bit error rate than a poor modem. Why does it matter if the modem is good? Well, I've found up to a factor of 10 improvement is not uncommon. Now, there's various ways that you can employ that factor of 10. One way is less power for a given application, and there's two sorts of power that matter in radios. There's your DC power consumption. You know, how long does your battery last? About a third of this is battery weight. So it's quite a significant part of the radio. If you can make that last a lot longer, that battery can be smaller, or just the radio can last longer for the same size battery. The other issue is transmit power and its ability to affect adjacent channels. When you transmit a signal, you also tend to transmit a little bit either side. So if someone's using radio spectrum either side of you, that can upset things. A good example was, or Tridge, your telemetry, how multiple radio transmitters in one given area, and we've seen this on Mark's balloons as well, can interfere with each other. So if you can lower your transmit power, life gets better for everyone else who's sharing your spectrum and adjacent spectrum. There's also the hardware cost and complexity. If this only has to transmit 1 watt instead of 10, well, it's going to cost a lot less to make. And longer range. Factor of 10 is roughly 4 times range, depending on the channel and how things are set up. So if you keep the power the same, and you have a better modem, you can get a longer range. You can also repurpose power to get a higher bit rate. If we keep the power at the same level, we can send 10 times as many bits as we could before if your modem is 10 times as good. And that can be quite useful as well. So modems matter. And the good news is they're only software. So it's kind of easy to swap a good one in for a bad one. This is how we characterise modems. Along the bottom here is your signal to noise ratio. And this is just scaled assuming we've got 1 bit per second modem. Just a modem running 1 bit per second with 1 hertz of RF bandwidth. And along the y-axis is the bit error rate. Now it's logarithmic, but if we look at a few lines across there, I wonder if my mouse will work. I'll use a pointer. This line here, 10 to the minus 1 means 10% bit errors. So, and down here, this horizontal line across here is 1% bit errors. 1 error in 1,000, 1 in 10,000. We're kind of interested in a roundabout here, at least I am, because that's where digital voice systems tend to fall over. So anything above here, I can't send speech through this modem that sounds any good. Anything beneath here, you can't tell the difference, even if it does have a few errors. So there's 3 lines on this curve, and they represent 3 different modems. The red one is the theory. That's as good as we can do. That's as good as the universe will allow, based on the physics of noise and things like that. The green one is a modem that I implemented that actually more or less meets that ideal performance. Modems are kind of cool in terms of engineering in that we can get as close as the universe will allow us. The physics is really well understood. There's very few endeavours in engineering where you can actually get that close. So that's one thing that continually, I guess, thrills me. The blue line is a poorly implemented modem that's commonly used in a lot of amateur radio services. Now, we can get a feel for how different they are by just tracing along at a given line. So, along at 1% errors, this requires 16 dB, and this one requires 9. That's about a 7 dB difference. The good news is it's only software, as I said. So you get the modem right, you can substitute it in, suddenly get 7 odd dB improvement in this case, or up to 10 dB when you take into account some other factors. That sort of thing matters to me, and that's one of the reasons I'm doing this work. More efficient, get things to work better. For the past few years, I've been playing with open source HF modems for the HF spectrum, which is this 3 to 30 megahertz shortwave radio area. They're a different game to this VHF channel. So about 12 months ago, I started investigating them and was amazed to find that they appear to be deliberately hobbled. That's not being entirely fair. In some cases, there's trade-offs. You may decide to have a poorer bit error rate, but a narrower range of frequencies that you use to conserve RF spectrum. But when I looked at it, it appeared like power and bits are being thrown away. If you've got a very strong signal, that doesn't matter. If you're talking to the guy next door, it won't matter. But I'm interested in these extremes and getting things to work as well as they can. So it matters to me, and I'm going to fix it, at least have a go at it. Now, as I said before, I've got a fair bit of experience with the codec, the protocol, and the modems, but the RF hardware was something that I had to start learning about. And because I'm trying to do something different and get the best performance I possibly can out of these systems, I needed to start developing my own hardware and understand how to do that. Now, when we get to RF hardware, there's several approaches we can take. The common one is to reflash or use new drivers on commodity hardware. There's a really good example of this. There's been a recent jailbreak of a DMR digital radio called the MD380. And this, you pull the radio apart, reflash it, reprogram the microcontroller, and you get a $200 hardware scanner for digital mobile radio, which until now has been kind of inaccessible. Lots of excitement about this in the hardware areas. My inbox has been spammed by people, breathless hackers, suggesting that I use this for my digital voice experiments for VHF radio. This is what the radio looks like, not dissimilar in appearance to one of these, but in this case it's a commercial digital radio for one of the current digital radio standards. Okay, but I'm not excited. I'm not excited by reflashing commodity hardware. The modem and radio performance is poor by design. I know the specifications. I can do much better, that factor of 10. The hardware doesn't do exactly what I want. I believe I can design hardware that does do exactly what I want. The other thing is the hardware might go away. These guys, you know, they might just decide to stop manufacturing it. They're not really related to our community. They don't really care. They'll just put it out of production when they're ready. I don't have control. Like no one can take away my Linux kernel source, right? Why should someone be able to take away my hardware when they're finished with it, or tell me how well it's going to work? The other issue here is that software now sets the performance. As I indicated with that modem, that was just a firmware change to get that extra performance. Software is now the key thing, not the hardware. And yet we seem to still be clinging to the fact that we have to use all these other guys' hardware if they're kind enough to, you know, manufacture it and let us in some way. So software sets performance, not the hardware that we actually accidentally get access to. So I'm not excited by reflashing, jailbreaks, repurposing. I want us to start thinking beyond repurposing existing hardware. Don't settle and don't compromise for what's out there at the moment. In the 21st century, software will be the key driver for all this radio stuff, not what hardware just happens to be out there. It's where all the effort and innovation lives already. If you look at any radio project, most of the work is in the firmware, not the hardware. Now, as a community, who does software best? The open source community. So it's all drifting towards us, what matters in this. That's where the value is shifting into the...
And this is VK3AML with a regular Saturday night test transmission. You're listening to David Rowe, VK5DGR, the developer of Codec2, FreeDV, and several other digital speech over ham radio systems, talking about the trends in digital transmission of speech becoming steadily more important as time goes on, particularly with the noise levels of metropolitan Australia. And the quality of the codecs in terms of reproduced speech is actually improving quite markedly, as you'll see from your second lecture, which we'll hear at 10:30. If those who are listening on 147.475 want to look in on the video, please Google the phrase VK3AML 23 July 2022. That's the phrase, Google it, VK3AML 23 July 2022, and that'll take you to our live stream. Back to David Rowe.
Open source. You certainly see that already in all the innovations people are doing with radios, even with the repurposed stuff. So I'm arguing that our community hacking into existing hardware is the wrong model. Hardware vendors instead need to work with us and for us. And the hardware vendors that realise that will get an edge, because we'll be working with them and helping them, and they'll be doing wonderful things. Or we can just design our own hardware, which is what I've been doing. The SM2000, it's fully open, hardware and software, so publishing all the designs as I go along using a bunch of open source software I've developed over the last few years and getting some more developed to run on it. The idea is to demonstrate 3 or 4 exciting possibilities for open source VHF radio, game changers, things that aren't being done in today's radio. I don't really know where it's going, because that's audacious enough. Doing 3 or 4 things that no one else is doing is quite enough for me for now. And I'm just going to release early and see what happens. A lot of these projects, you just scratch an itch, see what happens, and let's follow it from there. Now, what we're doing here, I guess the audacious bit, is a small team building 100% custom open hardware. But I've done this before several times. The most recent was this product called the SM1000. It's a little microcontroller board with audio interfaces that connects up to a legacy HF radio, analog HF radio, shortwave radio, and turns it into a digital one. The little microcontroller runs a modem and a codec and a bunch of control software, and it allows you to do digital voice on any old HF radio. Rather than what's happening for everyone else is they're saying, buy our brand new HF radio that has our proprietary digital voice system in it. This lets you use open source on any radio. And I did that with a team of a couple of other people, and we've put it into production. And that's it in its box. We've had 3 production runs now. We're selling them every day, and people are using them all over the world. So it's not the first time I've done this. Said, right, we need our hardware to do exactly what we want. Everyone else says, oh, use a Raspberry Pi and add this and add that. So no, we can get exactly what we want if we want to, and we'll go out and build it. And I teamed with a Chinese manufacturer and a retired US engineer, electronic engineer, who did the CAD layout for me. So a few paradigms I'd like to break with the SM2000, which is the new product. Fully open source, from antenna to speaker, electromagnetic to acoustic waves. Every single component of hardware or software that signal passes through is going to be open source. Now there's several things I'd like to try. One is wideband audio. These radios, since they were invented, have just sent 300 to about 3,000 hertz audio bandwidth through them. Telephone type quality audio. What happens if it sounds like Skype or an AM radio? Well, what will that be like? Well, we can try that with this hardware. Everything's software defined, the codec and the modem, so we can send, we'll probably use something like an open source codec like Opus to send information through it. We have that 10 times power advantage, remember? So we can employ that to send higher bit rate, higher quality audio if we want to. That's new. Relatively broadband data. Not much data goes on these sort of services. What it does is quite low bit rate. We believe we can get something like 10, 100 kilobits per second through these units, which is not broadband by our normal standards, but certainly is over VHF or UHF radio. Another idea I'd like to play with is this low-cost $100 repeater, which I'll deal with in the next slides. The 10 times power efficiency, I'd like to demonstrate that and make sure that all my numbers work in practice. And as I said, not quite sure where it's all going, but I'm going to have fun trying. It's open and collaborative, like all good projects are. My friend Rick, a retired engineer in the US, he's doing the CAD work. He's currently sending me, just today, the latest printed circuit boards, so we'll be ready to manufacture this thing in a few months, the first prototype. Brady is a student in the US. He's doing some modem porting for me. He's working hard on porting the modems we need for this system. All very ideal, very carefully tested and well-engineered modems. And I've been fortunate enough to have the assistance of some very kind RF engineers who've been helping out. One of them that's here today, Tibor, from commercial companies who are interested and have been very kind with their time and explanation, as I'm a bit of an RF noob, but it's good fun learning. Okay, repeaters. To extend the range of these things, they often put repeaters, usually positioned up on hilltops. These work really well when there's line of sight. So if this can see another antenna up on a hill, and that antenna can also see another friend of mine across town, then we can communicate via the repeater. They give you wide coverage. And you might only have just a few across town or something. They're not everywhere like a cell phone tower. One of the features of repeaters with analog radios, and indeed most of the new digital systems, is that they have to transmit and receive simultaneously. So when I press push to talk and start talking, the repeater's listening to me, and at the same time it's rebroadcasting that signal on a slightly different frequency. That's hard to do because you've got a very weak signal at the repeater site, mine, and it's transmitting a very strong signal right next to it from 2 antennas. The very strong signal it's transmitting can interfere with my weak receive signal. So you need to filter out, the receive one needs to filter out the adjacent strong transmit signal. It does that with something called a Diplexer, which is a really good filter. They're expensive and complex and hard to set up, and that's not going to change because of the mechanical nature of them. You also, because you're putting a fair bit of expense and using fairly complex hardware to make the repeater, you're not going to set up many. So site selection is important. You have to have the right sort of site across town. So site selection is an issue, which once again there aren't that many sites around. So it just gets hard to have more than 1 or 2 repeaters for a given service. That's a photo of a Diplexer, this complex filter that separates the very strong transmit signals from the very weak receive signals when they're both happening at the same time, when you're trying to simultaneously receive and transmit just a few hundred kilohertz or a few megahertz away. They look like big tin cans, and they use the physical properties to do that very strong filtering. Does anyone recognise that one? Okay. That's a VK5 repeater. Okay, so what I want to play with is can we make repeaters as common as these things? It is possible to use the same antenna for transmit and receive. If you do a transmit, stop, do a receive, do another transmit, stop, do a receive. That's called a time division multiplexing. So you multiplex the transmit and receive signals in time rather than frequency with a traditional analog repeater where you're, the transmit receive signals on separate frequency. So it's called TDMA, where you transmit for a little bit, then stop and listen. Very common with cell phones. It's been around for a while. Some mobile services are using it, but as far as I'm aware, no one's using it to make a really low-cost repeater that can run on regular radio hardware. Because it's just this constant transmit and receive cycle that you can do on a regular radio hardware, that hardware can be repurposed to be a repeater and a regular radio. So now what we have is a two-way radio that you change the software and it becomes a repeater. Now, that's a bit of a paradigm shift. One particular application is it might make them disposable. If you have an emergency situation, you could just stick these things on tops of trees all over town or throw them out of a helicopter or set them up with a little solar panel. And then you've got a radio network with repeaters that's much easier and cheaper to deploy. That paradigm's not possible with inexpensive existing repeaters. Makes the site less important, which means you can start thinking about putting them on multiple sites and not have to have the best site in town because you can employ 3 or 4 at almost zero cost. I'm not aware of this being done. It's not a new concept to me, but it seems to be forbidden by some of the current standards and things like that. If anyone does know of this sort of thing being done on a low-cost radio, I'd like to know for two-way radio. Okay, so to conclude, we've talked a little bit about open source VHF radio. I'd encourage you not to settle for accidental reflashing, but rather let's look for hardware vendors who will partner with us and work with us. Or you can build exactly what you need. It is getting easier. And a lot of the test equipment and hardware boards you can buy and things like that, little building blocks, are getting easier to find. I'm really interested in pushing open source right down the layers, all the software layers right down to the atoms. How deep can we go and still make it open source? And then when you do that, wonderful things can happen as you open up the layers. There's new things we can do that aren't being done out there. I've got a few links to this work. I've got a blog series on the SM2000 VHF radio development, and that's the URL of my blog. So that's the end of the talk, and I'd like to open it up for questions. Yeah.
David Rowe, VK5DGR, talking to a Linux conference in Geelong in 2016. Well, since then, in the 6 ensuing years, there have been quite a few improvements made collectively by hams operating in conference with David, and also by David himself, to the extent that some high-quality codecs for HF transmission are now available. And in a presentation in 2020, the MicroHams conference, done on the internet because of the COVID problem partially, David talked about this, and we got David's permission to run this. It's reasonably contemporary, so this is more or less representative of the digital speech over HF today. So back to VK5DGR David Rowe, talking about a more contemporary approach to digital speech over HF.
All right, so our next guest is David Rowe, VK5DGR. David Rowe was first licensed at the age of 14 in the early 1980s, operating a converted CB on 10 meters. Through the 1980s and high school, he progressed to a full call license and a TS520S. In 2009, he became interested in the problem of closed source codecs and digital voice and started working on FreeDV. David works part-time as an engineer for an Internet of Things startup where he helps build and test CubeSats. He likes to blog on his projects, drives a homebrew electric car, and also enjoys bike riding and sailing. Please welcome David Rowe. Thank you for being with us.
Thank you very much, and good morning to everyone, because it's 7:30 a.m. in Adelaide, South Australia. I made sure I got a late slot in the program. But nice day, sun's coming up, and we're just in the middle of our fall here. Okay, so I'll do the share screen thing. Okay, so today I'll be talking about FreeDV. I'd like to tell you a little bit about what FreeDV is, why you might want to use it, what's in it for the ham radio operators and experimenters, a little bit about how to get on the air with FreeDV. I'll also be talking about some of the people involved. There's quite a team of international people involved in contributing to the project in various different ways. A little bit about some of the current modes. As FreeDV develops, we've been developing different modes. We're currently up to 700C and 700D modes. 700 stands for how many bits per second. So that's coded speech at 700 bits per second. And also there's another mode we call 2020, which is pretty exciting. It uses something brand new called a neural net vocoder. So FreeDV is open source digital voice for HF and VHF radio. It consists of some software parts, including a voice codec, a modem, and some forward error correction, plus some sort of protocol code to wrap the whole thing together and make a complete usable digital voice system. The way you use it is through a GUI application. It's also available as a software library, so like an API that can be integrated into other SDR applications. A third way of using it is with some custom hardware, the SM1000 FreeDV adapter, and it's being developed by an international team of hams. Okay, so one of the reasons you might be interested in FreeDV is it really is on the leading edge of ham radio. We're starting to get low signal-to-noise ratio performance that's competitive with SSB. When you're using digital voice, there's no HF background noise. And in particular, it's a voice mode designed by hams for hams. This is ground-up construction of a digital voice system. We're not locked down by any commercial companies. We're not taking chipsets or algorithms or protocols from the commercial world. We're doing it all from the ground up. An important point is it's open source. Every line of code, in particular the codec and modem, which have traditionally been locked down by licenses and other closed source encumbrances, which means you weren't allowed to experiment with them. And we think, ham radio is all about experimentation, so those things should be open source and available to tinker with. So you've got this real freedom to experiment with no legal barriers, and we've lowered some of the technical barriers and given it a pretty low cost of entry. So how do you get on the air with FreeDV? The most popular way is with the GUI application. This combines the open source modem and Codec2, the voice codec. It comes in the form of a desktop GUI application for a variety of popular operating systems. And you connect this to your SSB HF radio, and then you can use it for digital voice. And it supports the various digital voice modes that are in FreeDV. Okay, so this is what the GUI application looks like. You have, hopefully my mouse will come up. In the center, there's various displays of the waveform. This is showing the spectrum up the top here, and then a waterfall display in the middle. Down the left-hand side, we have various diagnostics, such as signal-to-noise ratio, some indication of whether the modem's in sync, and some bit error rate statistics to sort of let you know how good the channel is. There's a little text channel down the bottom that you can use to put call sign and location information. And down the right-hand side, we've got some other controls, in particular the modes here. This is a somewhat older version. We've got quite a few more modes up here, but you can select which mode you want to operate in. And there's a PTT button here to put your radio into transmit and receive. through some sort of computer-rated control. So that's the FreeDV GUI application. The way it works is it connects to your PC, very similar to any other digital mode. You have some sort of sound interface device, which could be an external box, or some radios have USB sound cards in them. The difference is you need a second sound card, and that's for you, for your voice, because there's voice going into this system. So typically on transmit, you'd be talking into the microphone here, and it'd be going into FreeDV, and then getting put out onto the air as modem tones. And in receive, the opposite. You'd be receiving the modem tones on your radio into your PC and out of the headset. So typically we need another sound card. This is for transmit and receive operation. And that's usually a headset, just like we're using today. That's quite common. You can do receive only on FreeDV with a single sound card. So all you need is your built-in sound card to get started at receiving FreeDV signals. Okay, so the other way to get on the air with, or one of the other ways, with FreeDV is with the SM1000. This is a small custom hardware box that we've been developed. It's an embedded FreeDV system, no PC is required. It's sort of a small box form factor, about the size of a microphone, and you connect that to your SSB or FM radio and turn it into a digital voice radio. It has the built-in rig interfaces like transformers and opto-isolators to connect to your radio. That's all built in. And it's also open source hardware and software. We've ported all the FreeDV software across to run on a little microcontroller. It's a STM32 sort of thing you had in your router, 168 megahertz processor. And the hardware is also open source. We've published all the design files. However, we get them made commercially by our friends in China, and they're available for purchase. They currently run just two modes, 1600 and 700D. The hardware was designed by Rick, and his call sign details there. Several years ago, we had a great time building that project together. That's a little bit about what the that's a photo of the SM1000. This shows the rear of the case with all the connections to your radio. There's 3.5 millimeter connections for the audio. You can also plug in a headset and push to talk, a microphone switch, things like that. It can also connect to your radio through an RJ45 for the radios that support that. And there's a small patch panel inside that lets you configure it for your particular radio's RJ45 configuration. A few little trimmers that you set up for your radio to get the levels right. And on the front, which I haven't shown here, but there's volume control and indicator LEDs, mode switches, that sort of thing. The other way you can use FreeDV is through the API. There's just an open source C library. It comes in C code form, and that can be compiled and included in any SDR project. So there's a couple of example projects here. One is the UH SDR project from Danilo and his team, and that's a STM32 based SDR receiver. Uses a similar processor to what we've got on the SM1000, and Danilo's done a lot of fine work on optimizing the FreeDV code to run in real time with all the other signal processing that's going on that radio. So that's an example of using the FreeDV library inside a software-defined radio, an embedded one. Also, the Quisk project from Jim. He's also embedded. That's a GUI-based desktop-type application, and that's also included FreeDV just by linking in the library. And of course, it's all open source, no license fees, so quite easy and straightforward to use. I'd like to talk a little bit about some of the people who are involved in the project. This is Steve. He's been a great help with the OFDM modem development. Now, the OFDM modem is what we use for the current 700D and 2020 modes, and that provides very good performance with a very small bandwidth. And Steve was involved with a lot of the development in that, and has done a fine job and continues to help maintain the modem. So thank you, Steve. There's a lot of software in this project, hundreds and hundreds of files, and one of the sort of plumbing tasks we need to do is manage to build all that software, and that's done with a makefile system. And Richard is consistently on a weekly basis maintaining that and keeping that running. So really important job, and Richard does a fine job in helping us just keep all this complicated software building cleanly across multiple operating systems and applications. So thank you, Richard. Munir is the Osx maintainer. He's helping us. As I said, the FreeDV GUI application runs on various different operating systems, and he's specialising in keeping it running on Osx, which is a slightly different version of Unix to Linux and FreeBSD, etc. So it requires a little bit of tweaking to keep it running on Osx, and Munir's done a fine job with that recently. Don did some great work over the last couple of years in getting the FreeDV 700D mode ported across to the STM1000, which runs the STM32 processor. Now, this is a very complicated algorithm, and I've got a little bit more about that on the next slide. But Don has brought a lot of experience and did a fine job on that. So this was a project, I guess, over the last couple of years that we worked on together. Don brought a lot of his experience as a retired embedded systems engineer. And there's a lot of complex DSP going on in this algorithm. We've got the voice codec, we've got the OFDM modem that Steve developed, and we've got some LDPC forward error correction codes that are pretty close to state of the art. And we've got all this running on a little memory constrained system in real time on a little 160 megahertz processor. The other thing that Don and Danilo brought to this project was some very professional automated testing. We have around 40 automated tests just for the STM32 that test various aspects of the software at a touch of a button, which takes a lot of load off us as the developers and lets us know very quickly when we break things. And we break things all the time, so we need these tests to know that things keep running. So we released the new SM1000 firmware with the 700D mode mid last year. There's been a few tweaks since then, and it's we had fun. Did some fine work working together from different points in the world. Danilo's in Germany, Don's very close to where the conference is being hosted, and I'm down here in South Australia. Okay, the FreeDV 700C and 700D modes, they're currently the sort of standard mode for HF operation. 700C came first, and then had a few brainstorms and developed that into 700D. They both use the same 700 bits per second codec, so on a good channel, they'll both sound identically in terms of speech quality. But they have a different approach to the modem and the forward error correction and how we overcome the difficulties of the HF channel. And HF channels are hard to get digital voice over. SSB does do a fine job, and it's only recently that we're starting to compete with SSB, in particular at low signal-to-noise ratios. The quality of this codec is low to moderate. It does take a bit of getting used to, but once you do get used to it, basically it carries rag-chew conversation just fine. And people get used to it after a little while. SSB does take some getting used to for the non-people who aren't used to it as well. So it's just a bit of a different experience, but a similar learning curve. These two modes have allowed us to get a lot of on-air experience, and we're actually finding that one works better than the other in different conditions. For example, 700C transmits the voice signal twice at two different frequencies. And that's like transmit diversity that overcomes some of the fading. If one half of the channel's faded, then maybe the other half's okay. And the demodulator puts those two sets of carriers back together, and you get a reasonable sort of signal. 700D sends the signal once but puts forward error correction on it. So that corrects the errors using the forward error correction bit rather than 700C, which uses transmit diversity. So we found that 700C works better on fast fading channels, and 700D works better on slow fading, low SNR channels. So 700D will go a bit lower in SNR, down to as low as -2 dB SNR. And 700C is a bit better when you've got those really fast fades. Why this is happening? Well, we're still working that out. This is experimental radio. The two waveforms have different approaches, and this is the sort of thing that we investigate and use those lessons to push the whole system forward. Okay, the next thing that's been pretty exciting over the last year or so is neural net speech coding, in particular LPCnet. Now, over the last several years, there's been a bit of a breakthrough in the quality of speech synthesis that's been pioneered by Google, using techniques such as machine learning and deep learning. It was initially developed for speech synthesis, but it was applied to speech coding in 2018. And they actually used Codec2 to demonstrate that system. They used the Codec2 encoder, but they swapped out the Codec2 decoder and used a special neural net decoder, and that made vastly better speech quality with the same bit stream. So they didn't change the encoder at all. They just swapped out the speech decoder and got vastly better quality. So it showed that using these neural net techniques, we can get much better quality, but in a lower bit rate. However, this initial work was closed source, and it required a GPU card, a GPU graphics card to run. So very heavy in CPU loading. Enter John Mark, a friend of mine who's a Canadian open source developer. He looked at these neural net systems and developed a new one called LPCnet, which is both open source and efficient. And he managed to get it to the point where it could run on high-end desktop CPUs. Now, I took John Mark's work and have been applying it to digital voice over HF radio in FreeDV. So thank you, John Mark, for that work. Which brought us the FreeDV 2020 mode. So we use the LPCnet codec, which has been quantized to around about 1700 bits per second. And on top of that, we apply a powerful forward error correction code, an LDPC code, low density parity check code, that was developed by Bill, a colleague of mine here in South Australia. We used the same modem. So we took the modem that was working fairly well for 700D that was developed by Steve. And what we've got, with a bit of help from integration, thank you, Brad. He did a lot of work on getting the GUI side and audio streams running. We've got 8 kilohertz audio. So it's similar audio to what we're using today for this. 8 kilohertz audio, AM watt radio type broadcast bandwidth.
And I'll just stop David 5DGR there to say this is VK3AML with the regular Saturday night test transmission. On this occasion, a speech by David Rowe, VK5DGR, on the development of speech codecs for HF radio. And in a few moments he will actually play some examples. The very first codecs for FreeDV sounded pretty bad, but as time has gone on, they're approaching broadcast quality more and more closely, as you will see. He's giving a demonstration soon. This is VK3AML. Back to David Rowe, VK5DGR.
But we can send it in only 1600 hertz of RF bandwidth. So it uses less than a regular SSB channel for the RF bandwidth to get high quality audio. This is available in FreeDV 1.4 now, which you can download at any time. And I think it's the first neural net vocoder on air, at least. I haven't heard of anyone else doing it. So this is ham radio, leading the pack. There's nothing like it in the commercial or closed source world. Okay, now I'll try a demo. I'll have to try and share my audio, and I'll show you the difference between regular SSB and FreeDV 2020. Okay, so the first thing I'll play is the original. This is a little bit of broadcast audio from our regional Australian weekly broadcast. I'll then play what it sounds like on SSB at about a 10 dB signal to noise ratio, and then I'll play it to you coded using the FreeDV 2020 algorithm, the LPCnet codec. Okay, so original audio.
From Australia, this is VK1WIA.
Okay, is that coming through okay, organisers? Good, thank you. I'll now play what it sounds like as SSB.
From Australia, this is VK1WIA.
And now with FreeDV 2020.
From Australia, this is VK1WIA.
So there you go, that's the difference in quality.
I'll just repeat that because that indicates just how good this is getting.
The FreeDV 2020.
From Australia, this is VK1WIA.
So there you go, that's the difference in quality. I'll play the two again. This is the SSB.
From Australia, this is VK1WIA.
And the FreeDV 2020.
From Australia, this is VK1WIA.
Okay, I've got some slightly longer samples here that I'll do again with the SSB and the FreeDV 2020. This is once again an excerpt from our local news broadcast. This is the SSB at 10 dB SNR.
From Australia, this is VK1WIA and the weekly WIA amateur radio news service on RF, internet streaming and text at wia.org.au. Hello there, I'm Graham, VK4BB, the national news for week commencing January 2019 in our 24th year of non-stop news and a pretty eventful and violent week at the WIA news desk this week.
Okay, now the FreeDV 2020.
From Australia, this is VK1WIA and the weekly WIA amateur radio news service on RF, internet streaming and text at wia.org.au.
Hello there, I'm Graham, VK4BB, the national news for week commencing January 2019 in our 24th year of non-stop news and a pretty eventful and violent week at the WIA news desk this week.
Okay, so there you go. So you can see the quality is quite a bit higher. It's still not artifact free. It's not quite as high quality as the codecs I'm using at the moment, but it's doing it a very small fraction of the bit rate. Also, it's just our starting point. We will get better. Okay, now I'd like to show you a demonstration of FreeDV 700D. Now this is much lower speech quality, but it's designed for lower SNR channels, in particular competing at the very, where SSB is barely usable. So we've chosen a day where we had a really bad path to demonstrate the two, and this is between Adelaide and Bay of Islands, which is just north of Auckland, New Zealand, and that's about 3,200 kilometres path. Now, this has a lot of noise in it. Please lower your volume a little bit. I don't want to hurt your ears. So it's a mixture of analog and SSB. Sorry, it starts a mixture of SSB and 700D, starting with the SSB, then digital, then back to SSB.
And this is Victor Kilo 5, Quebec, India. Victor Kilo 5, Quebec, India, running approximately 100 watts TDP. Viewing and fading on the signal at the moment. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. This is FreeDV 700D, approximately 100 watts through a very, very poor signal path. Victor Kilo 5, Quebec, India, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And now switching back to analog. And this is Victor Kilo 5, Quebec, India, Victor Kilo 5, Quebec.
Okay, so you can sort of hear the difference there. So that was Mark, VK5QI, doing some tests of the early FreeDV 700D system. In the middle of it too, the digital broke up as well. It reached that threshold where the modem lost it. So that's sort of right at the edge. Okay. I'd like to talk now about a couple of interesting ways people have been using FreeDV. You throw this stuff out in the wild, especially when it's open source, and you never know who's going to email you and say, look what I've done. One thing that's been happening is a group of people in both the UK and in South America have been using FreeDV over Kiwi SDRs, so network of web-based SDRs that you can log onto and use as a remote receiver. What you can do is using virtual audio cables and some plumbing in your computer is pipe the audio from these web-based SDRs, like Kiwi SDRs, into FreeDV, and then use that as your remote receiver. So that's been used for a couple of purposes. One is to assist in propagation. If you don't have a path, you can choose a receiver that might be able to pick it up. Sometimes that's a bit closer, or sometimes it's just a slightly different location in your own city or state. Okay, so I'd like to talk about some of the novel usages of FreeDV. There's been a group of UK and South American hams who have been using Kiwi SDRs as the receivers for their FreeDV QSOs. So you run the SDR on your web browser, and then you can pipe the audio through to the input of FreeDV using virtual audio cables. And let's get rid of oops, that's Jose. Okay, so a couple of reasons people do this. One is to assist in propagation, and another is to get around urban noise. So if your receiver is anything like mine or your location, it's getting very hard to receive some HF signals locally. Two people who've been using it to get over propagation are Jose, who lives in small town in southern Argentina, and Peter, who lives in Melbourne, Victoria, which is about 100 kilometres east of where I am, one of the major Australian cities. They use a variety of SDRs, but they often settle on a common meeting point at an Auckland SDR, which is 3,000 kilometres from Peter and 10,000 from Jose. And they manage to make QSOs over this path. They tend to use FreeDV 700C. That seems to work a lot better over what's a southern polar path. You get quite a lot of fading. Fairly modest equipment. For example, Jose is just using 40 watts and a delta loop. And what they're doing with this is they're getting daily RADTU type conversations. This is not shouting your call sign 5 times and reporting 5 by 9. This is talking about the grandkids and what's happening and the weather and things like that. They're doing that on modest power levels over a pretty long path, and they're doing it every day. They're doing it reliably. So it just shows what can be done with a little bit of assistance from the SDRs here. So this is Jose. Now, Jose is possibly the most enthusiastic FreeDV user on the planet. He's constantly on the mailing lists and popping up in all sorts of places, in particular via the SDRs. Very enthusiastic, lovely gentleman. He's a semi-retired surgeon. He's been helping out lately, doing a bit of consulting with the coronavirus via video. So he stepped back in to help out there. He comes from 3 generations of hams, his father, his son and himself, which is wonderful. And he's very done a lot of work in using these Keeley SDRs to bridge propagation and make contacts all over the world pretty much any time. Some other experiments they've done with Peter is full duplex calls using FreeDV. So that's pretty interesting. Unfortunately, the latency through the SDRs and FreeDV is pretty high, so you've got several seconds, but nevertheless, full duplex is pretty interesting. And he's operating every day on FreeDV with Peter and with other people. And this is Peter in Melbourne. Looks like he's running FreeDV on a couple of laptops in the photo there. So that's a typical sort of operator situation. Peter's a retired electrical engineer and a radio historian. He's done some wonderful work on history of radio, going right back to the beginning of the last century, and some very early contacts he's documented and written several articles and books on the subject. He's worked quite a few FreeDV stations over the past years, and his partner is also a ham that runs FreeDV. And he gets a bit teased because her voice sounds a bit better over FreeDV than he does, apparently. So a bit of a friendly competition there. And his message to everyone was that if he can do it, you guys can do it. Okay, another interesting application is over QO100. A friend of mine, Gerhard in Austria, has access to QO100 as it's sitting, as you probably all know, it's sitting geostationary over covering Africa and Europe and the Middle East. And he was interested in running FreeDV 2020 over the satellite. So it's geosynchronous. It has, the interesting thing is, unlike many other satellites, it's got a linear transponder, so it can run SSB. However, there are bandwidth limitations, which rules out most other digital modes except for FreeDV, which was designed for narrow bandwidth. So Gerhard started running 2020 that had problems with decoding and synchronization of the signal. So he sent us a few samples, and Steve and I, sort of equidistant around the world from Gerhard, went to work on this. And we discovered that there was a lot more phase noise, so the phase of the signal was drifting around all over the place compared to, say, the HF channel. And the reason for that is probably all of the up and down conversion stages, all those local oscillators spinning around when you're getting up and down from microwave frequencies back to baseband. So we modified the modem. It's open source, right? We got stuck into it. We looked at what was wrong, and we modified the modem to suit the channel. And then we submitted the code back to Gerhard for testing. So it was kind of nice. 3 of us were working in 3 different time zones, all around the world from each other, to code, test, and debug. And we got it working. He can make 2020 contacts. Still a few little bugs with initial synchronization, but certainly usable. And people are also running some of the other FreeDV modes over QO100 as well. It's an interesting, the channel doesn't have much fading, and it's about 10 dB SNR all the time. So the quality is a little bit like what I demonstrated to you before. And that's Gerhard's antenna that he uses, one of the antennas that he uses for QO100. Okay, why not FreeDV? It's not that popular. There aren't that too many people out there at the moment. So one of the complaints is, who do I talk to? There is a bit of difficulty in setup with the 2 sound cards. It takes a bit of work, and that sometimes can be difficult. It's easier if you get some help, but some people struggle with that. This is experimental ham radio. It's not like DRM where it comes in a box, you can press a button and use it. Some effort is required to use it and get it set up. Once you're experienced with it, it's fairly straightforward. It's constantly evolving. We're pushing new modes out, so some people like things to be the same. I guess my personality is I like to be on the bleeding edge and experimenting. I'm not that interested in Windows USB sound card driver problems. I'm more interested in getting a new mode working. So that's where I like to play. There's little commercial support, except Flex does support some older modes. Some people complain about the speech quality with the lower bitrate modes, but we've found that one gets used to that, and that it carries conversation just fine. So it's a little bit like SSB in the early 1950s, pioneering, leading edge stuff. Some of the technologies that we get to play with, well, it's got the world's only open source low bitrate speech codec in it. The modem we've got is a coherent OFDM QPSK HF modem. A lot of HF modems are differential PSK, and we can get much better performance using coherent techniques, several dBs. The raw modem, we send around 1400 bits per second at -2 dB SNR, or 4000 bits per second at 2 dB SNR for the 2020 mode. We don't really go higher in that in bitrate because we don't need it. It's a low bitrate speech coding. Some of the other technology in there is we have an FSK modem who has ideal performance. It's bang on theory. We use that for some modes. There's some powerful forward error correction technology in there. Neural net speech coding. The whole thing runs cross-platform on a variety of operating systems and hardware platforms. We have some of this code running on a small microcontroller and on Raspberry Pis. We work with each other on GitHub and have a bunch of automated tests on Travis.
I'll just interrupt David Rowe, 5DGR there, to say this is VK3AML. We'll be opening up in about 6 minutes' time for QSO on 147.475. In the meantime, if you want to see the visuals that go with this lecture, please Google VK3AML 23 July 2022 and you should find us there. That is Google VK3AML 23 July 2022 and you should see the visuals. Back to David Rowe for the next 5 minutes and then QSO.
Around about 100 of them run now when we modify any code. We can run through a suite of tests and make sure it keeps running. I do all my development on Linux, and I use a Docker container that runs Fedora Linux to build the Windows. There's a bunch of cross-compilers that build the Windows code for me. So I can fix a bug in Linux, press a button, and it pops out Windows installers in a few minutes that I can post on my website for the Windows people to try. And the whole lot is open source. So anyone's able to get in there, experiment, play around. Just an example of I guess, what I do day to day. I do work a few days a week, part-time, but then in terms of my own projects, this week I've been looking at some tests on Osx, reviewing some of the fine work that Munir was doing. Another nice gentleman from the UK submitted some fixes for the 800 bits per second FSK mode, and I've worked on those with him. I've been sidetracked into a new balloon telemetry protocol. We've done a little bit of work on telemetry protocols for high altitude balloons. I'm working on that with Mark and Bill. And this protocol is going to work down to minus 160 dBm signal strengths. Every 20 seconds you'll get a packet of 128 or 256 bits at very low signal levels. And fixing my fan dipole. I do all right in the software, but I'm not so great on the hardware. So I've got to the point where my dipole's not falling down every week now. It's only falling down once every 2 months. So that's the sort of thing I've been up to. Medium term, I guess where I'm going with this work, I like the experimental side. So I'm looking at doing some more work with the neural networks, and in particular how to combine the neural networks and the traditional quantization techniques we use for speech coding. And the general direction here is improving the speech quality at a given bit rate and getting it more robust over this tricky HF channel. So that's kind of the general direction that I'm moving in. Okay, so just to summarise, FreeDV is open source for digital voice. With the 700Z mode, we have some cases where we can outperform SSB at low SNR. 2020 is kind of exciting. That uses one of these brand new neural net vocoders and lets you send 8 kilohertz wide audio in 1600 hertz of RF bandwidth. The major resource is the freedv.org website. You can download a bunch of the software you need to get started, and it's got links for support. And I've been told by Walter, K5WH, that he's standing by on 14.236 if anyone would like to have a QSO on FreeDV, and a bunch of the other guys. So.
That applied to the original transmit date of this speech back to David Rowe.
To use FreeDV in North America. And then there's my blog as well. Okay, so that's the end of the formal talk, but happy to open up for questions or move to the meeting room, whatever works.
I do have some questions actually that came from the YouTube stream.
Sure.
And let's see here. So the first one is, does the C library still require floating point?
Yes.
That was easy.
Yeah, not much work's been gone into making it fixed point.
Fixed point. I remember seeing some response some years ago that more and more devices are getting floating point anyway. So.
Yeah, we have it on our smallest platform, so we haven't seen it as a big problem.
Right. So you mentioned in here that there had to be 2 cards to configure. Is you're talking about each end of the link, or are you talking about? I don't need on any one station. I don't need 2 sound cards, do I?
Yes, you need 2 sound cards at your station. So you need one for your headset and microphone, and one talking to the radio. That's for that's for a transmit receive.
Right. Okay.
2 sound cards on every station.
Sure. Okay, that makes sense. What else do we have here? I wonder if we could replace Ambi with Codec2 on Open. Maybe I should put my glasses on. Open GD77.
I don't know what OpenGD77 is.
Neither do I.
Yeah. Happy to address that in an email or in the...
Right, so the other one here says, I'm interested in the possibility of integrating FreeDV-based networks into existing infrastructure, e.g. IRLP, so VHF users in cities can be linked to remote areas via HF.
Sure, yeah. Well, there's a lot of the, like the libraries and that sort of thing are there, ready to be linked into other applications, so that's certainly possible.
Excellent. All right. I don't think I have any more questions at the moment. Nothing. All right. I think that's all we have for now. If you're available to hang out in the room, I'm sure there are more questions. There simply must be.
And that was a speech by David Rowe, VK3AML. I'll just go back to webcam. And he was talking about his baby, basically, FreeDV and the famous Codec2, which is a digital transmission codec specifically designed for difficult paths on ham radio, with lots of variations now, including one which you heard there with reasonably high audio quality, far better than I was hearing about 8 years ago when FreeDV first came out. So watch this space. It's going to be very interesting to see what happens to ham radio, and specifically digital systems via ham radio over the next 10 years. That in combination with software-defined transceivers, which are bound to become the mainstream rather than the top of ham radio in the next few years, probably will convert people from what we would call communications quality to something slightly better over bands like 20 metres. One particular application which struck me for FreeDV is operation on 600 metres, the 472 to 479 kilohertz band, where sideband no wider than 2.1 kilohertz is permitted. Now, 2.1 kilohertz of normal sideband sounds pretty awful. But obviously, with that FreeDV system, it would be legal to transmit it on 600 metres. And 600 metres additionally operates principally via ground wave out to many hundreds of kilometres, and doesn't have very much multipath or selective fade. So VK3HP and I, some 8 years ago, transmitted digital slow scan TV between our QDHs on 600 metres. 3HP Grant from Frankston South and me here in Burwood East, and had no troubles receiving orthogonal frequency division multiplex, multi-subcarrier digital pictures on that band, even though the sig to noise was very low, because the phase noise was very low, and the phase coherence of transmissions over 600 metres compared to HF is exceptional. So there's a new potential application for the low-frequency amateur band, 600 metres, in digital transmission, because it seems that it would lend itself excellently to transmissions in that mode. Okay, we're running a little late compared to normal for our live QSOs. I know that Dave Ranson is not with us this week. I did announce last week that there would be no QSO this week, but as a result of a cancellation of a social event that Prue and I were invited to, cancelled by COVID. Unfortunately, several of the people that were coming came down with COVID. I'm back in front of the microphone and in front of the live stream tonight, unexpectedly. Even more unexpected is that my TCP/IP has been screwed around by this little switching unit in front of me, and so my monitoring of my own stream is not all that it could be. And I see Rolly is with us from New Zealand, and it must be something like 2 a.m. over there, so he's a stalwart. Thank you, Rolly, over in Auckland, I think. Or is it Tauranga? I'm not quite sure, one or the other. So this is VK3AML, now with the test transmission principally dealing with digital voice on HF complete. Now calling CQ for a QSO, and let's see who we can get on 147.475. VK3AML, standing by for any calls.
Yeah, VK3 Alpha Charlie Zulu.
VK3 ECG is here. VK3 DLW.
Oh, I wasn't expecting Dave. I thought he'd be well and truly. Hello, Peter. Hello, Dave. And hello, Mr. C. God, can I remember your surname? Dear, oh dear, I've blanked on your Christian name. Mr. Cook. Well, look, I'll put it over to Peter first. That'll mask my embarrassment. VK3ACZ and group, VK3AML. How's your week been, Peter?
VK3AML in the group, VK3ACZ. Good evening, Chris, Graham and Dave. And good to hear you on, Dave, since your non-show had already been announced. Good stuff. Yeah, it's been a good week, Chris. The Sherbrooke radio camp up at Heathcote, it got down to -8 at one stage. But at first, comments about tonight's video, where you mentioned that there'd been drop frames and you stopped the particular part of your test transmission. There was no evidence of any faltering at my end, so I don't know whether that helps or hinders what you experienced at yours. And funny thing with the examples of the recordings, I don't know. It's obviously what you're used to, but I preferred the single sideband. Isn't that funny? I guess I'm so used to it. I almost got excited hearing the sound of it, especially compared to the digital. The digital had a strange raspiness to it that didn't sound natural, which is an absurd thing to say, really, when you compare it to the lack of quality of sideband. But that's your mileage will vary, obviously, and it's in the ears of the beholder. But there you go. I'm just being silly, I suppose. Anyway, back to the subject of the Heathcote camp. I had one experience where I wanted to join a 70 centimetre net on the RBA link system, and I went up a hill called Mount Ida near Heathcote, and Dr. Google said it was 96 kilometres to the nearest 70 centimetre repeater at Mount Malagal, and I made it very comfortably and joined the group on Wednesday night, so that was fantastic. So long as you've got height, UHF is fine for distance communications, not that 96 is anything of a record to be raved about. But anyway, highlights for the week with DX, of course, wouldn't you know? Mike Delta 0 Charlie Charlie Echo. Anytime I hear a prefix and I have to look up what it is, there's room for me to get excited. And I was so thrilled to think that I'd gone to the Isle of Man this week on 20 metres as my first time. And a real highlight today, though it was only a 5x1 back to me, a 5x3 that I sent, was Namibia. The second time I've contacted Victor 51 Mike Alpha, Mike over there in Namibia. But the thing was, I was using a centre-loaded whip on a magnetic base on the car. Very thrilled to be able to do the long path to Namibia, which QRZ.com says is 28,500 kilometres on the long path. So that's a bit of my excitement for the week. Graham will have a little bit more because he came up and spent some time with us there and worked a bit of DX too. He did a good job. And thank you, as always, for your broadcast. And I'd completely forgotten, Chris, that it wasn't going to be on this week. I guess I take for granted in the nicest possible way that you're going to be there, and I just switched on assuming you would be, and everything was as per normal, and it was only when you mentioned it that I realised it wasn't supposed to happen tonight. Anyway, so glad that it did. Rain is pelting down outside in the eastern suburbs. I'm sure it is at your place too. Back to you, Chris. VK3AML in the group, VK3ACZ.
Yeah, Peter. Yesterday was beautiful. This is a crap day by comparison. We had a get-together for, you'll laugh, my grade 6 friends of the year 1965. We're still in contact, still meeting after 57 years, and we're planning a big get-together for the 30th of August. There are still about 16 of a class of 37 in contact with each other after nearly 60 years. We've all grown up together, so consequently we understand each other's foibles. And had a meeting at the old stamping ground down Taronga Road, East Hawthorn, which has gone from being a slightly down at heel suburb to being very affluent. And who should walk past the front door of the little restaurant we're in? Some of the people there cheered. I didn't. Was our former treasurer, Josh Frydenberg, smiling, shaking hands, and I wouldn't mind betting if there were babies around he'd be kissing them too. I didn't quite get to the point of suggesting that he kisses a certain part of my anatomy that I face away from. Oh, I better get off that subject quickly. But yeah, look, getting back to the digital audio, from my point of view, and I'm sure that David Rowe would understand where I'm coming from the point of view of reasonable audio quality, is it's a watch this space activity. I wasn't interested at all in the initial quality of FreeDV. I'm not particularly a DX chaser. As you know, Peter, I'll be in it if it's around, but I'm not particularly concentrating on that. I'm an audio man, really. And to me, looking at the most recent FreeDV, the 2020 version, to me it's almost getting to the point where I would use it, particularly in its less compressed version. And David was talking also there about a VHF version, broader bandwidth, that would be equivalent to Skype in quality, and that interests me. But the really heavily compressed stuff, as heard through the Bay of Islands in New Zealand over 3,000 kilometres, a significant achievement, but the audio quality, in spite of the fact that it's very much better in terms of intelligibility than analogue, still doesn't really turn me on. It's just that if you're into audio quality, your ears become attuned to the point where bad audio quality, and Dave, being into music, will understand this, bad audio quality, I find physically painful. I'm not exaggerating. I hear distorted bad audio and it produces an intense feeling of nausea. And with that, I'll hand it round to Dave, the unexpected appearance this week after the announcements of last week. I'm just wondering if you've been shut down by COVID as well, Dave. VK3CG and Group. And I'm sorry about calling you Cook, Graham, but I needed to prompt myself with some visuals on paper. VK3CG and Group. Over to you, Dave. Hope you've had a good week. VK3AML.
Yeah, VK3AML on the group, VK3CG. So sorry if I caused confusion. I'm actually going to be away sort of starting sort of week after effectively the 1st of August. So I was around and I saw you were going to be back on Facebook. So I thought, I will look in. I'm not entirely sure whether I'll be available next week or not, as I'm beginning all my stuff sorted out for travelling. But I'm also trying to lock myself down a little bit because the Omicron, certainly BA5 now, is really beginning to grow significantly. And as you know, with the music side, I sing in a couple of choirs, and again, they've been significantly hit by people. So I'm being very careful, and I think I'm going to not go to anything next week so that I don't get myself into difficulties. I think BA5 now is pretty much is the dominant strain, and unfortunately it seems to be escaping some of the immune systems that people might have gathered from vaccines and some natural immunity issues and so on, but at a sort of cohort level. Having said that, fortunately, we're not seeing tremendous increases in significant hospital admissions and deaths and things like that. So that's a good sign. But the fact it's so transmissible, I wouldn't be surprised if that's what the American president has got. Given that it's just they must take an awful lot of care to ensure those people are not exposed, but it is just so infectious that you've got a very high risk, and I certainly don't want to get myself in a situation of having to postpone anything, because that would be a bit disastrous. So I'm being a little bit more careful at the moment. I saw you were doing some things with the screen, and you were talking about getting the Zoom going. I wondered how that was going as a plan. I'm sure that will be certainly interesting, and when I am over in the UK, if I can, I'll try to listen in, certainly from YouTube if I can, depending what family are doing and things like that. But if there was a Zoom thing, then perhaps I might be joining. I'm actually thinking at the moment about what I might take with me in the way of radio stuff. It has to be incredibly portable, so I'm having a look around, seeing what I might do, and I might not. But I'll probably take a handheld of some sort, because there is a reasonably close 70 SIMs and repeater in the UK, and I still have my UK call sign, which is only there really because you don't pay for your call sign, for your license anymore in the UK. You just notify the agency on Ofcom at least once in 3 years that is still your address, and you still want a license. You do that online, and so that's it. It's like a permanent thing. So I've got an address in the UK I can use for that, for family and so on, and so I can simply just move into the other call sign. So I don't have to think about reciprocals and things like that, which is quite nice. Yes, so that's what's been going on. I must admit, Peter, that sounds pretty impressive, getting the Bibby on a loaded whip. Is it center loaded? One of the center loaded diamonds or something like that? I mean, they're the ones that seem to have quite a good reputation, particularly for not getting too much interference from adjacent objects on cars and things like that. So I'm wondering what sort of things you were actually using there. But I do know what you mean, Chris, about poor audio actually grating, and it's extremely tiring to listen to for a long time. That's the other thing I think about it. It's quite fatiguing, and after a while you sort of lose concentration. If you are struggling to listen to it for whatever reason, then I think after a while it gets harder, because you simply get sort of a sort of mental fatigue. It's a bit like someone repeatedly, singing or playing out of key. It actually gets quite painful after a while. Anyway, back to you. VK3AML in the group, VK3ECG.
Yeah, Dave, the aspect of listener fatigue is something that frequently isn't addressed by people on ham radio who emphasise communications quality. And I put that in inverted commas because quite frequently bad quality passes for communications quality with some people. Oh, my transmitter's okay, it's communications quality. Oh, Christ. The number of times I've heard that, and it's just plain bad. It's clipped, it's got into modulation. Yeah. But the other thing is that something that I found interesting, that added interest to the transmissions that I used to hear from the old 3AML, who was running a lot of compression, and usually at his house a lot of things were going on, was that you had a sense from the background noise of the acoustic environment that the person was sitting in. It enabled you to create a mental picture of what was going on, and that, almost as much as the speech, gave you an idea of the transmitting environment, and it was a major part of the interest of Tony's very high quality AM transmissions on 160 metres. And in those days, most of us who were seriously interested in that were living reasonably in a city. I was in Hawthorne, East Hawthorne. Dave, 3ASC, was in South Caulfield, so was VK3BEK, who's now VK3EN, Paul Higgins. Quite a few of the other 160 metre people were all within about 5 miles of each other, so you didn't need a huge number of watts to have quite a bit of sig to noise. So good sig to noise, broad bandwidth, high quality audio, and you could listen to that for hours on end and not get really tired by it. Whereas if you're working your way through selective fade, distortion, people with overdriven linear amplifiers, and people encroaching on your own frequency unnecessarily, which often happens on 20 metres, it really does grate. And I can understand why, under those circumstances, some people choose just to transmit their call sign, yell their call sign 3 or 4 times, transmit 5.9, and it's usually anything but 5.9. It's about 4.3 in many cases, and then be on their way. Not my idea of an interesting diversion. I guess that's because I'm into rag chewing, as you no doubt will have noticed. I'll hand it round. Oh, and Zoom. Well, this afternoon we tried to get this computer and the computer through there, which is actually streaming me at the moment, working together by using this TP-Link gigabit switch. It's a switching unit that allows 2 computers to run on a single Ethernet cable, and Here is the single Ethernet cable, which goes some 20 metres through the roof behind me to the modem at the other end of the house, the front of the house. And yes, we got it set up. There was an IT lady with me. First, it would allow one computer to operate and the other computer to operate, but not at the same time. So computer number 1 operated, computer number 2 didn't. Then we started the 2 computers again. Then number 2 would operate, but not number 1. Then we started it again, and neither computer would connect to internet. Then we started it again, and both computers would connect to internet, but only for 5 minutes. I then was handed, and those on the stream will be able to see this suggestion on their configuration handout, pamphlet, that this switch is plug and play. Well, if it's plug and play, why does it require instructions like 1. Find out the IP address of the switch. By default, the switch receives an IP address from a DHCP server for a router that functions as a DHCP server in your network. You can find out this IP address on the DHCP server. Well, not knowing what a DHCP server is, it was rather difficult. And then they go on. If the switch cannot receive an IP address from the DHCP server, it uses the static IP address, 9 figures follow, with a subnet mask, whatever that is, and another 9 figures follow. Point 2, configure IP address on your PC to make sure the switch and PC are in the same subnet. Pardon? If the switch uses an IP address assigned by a DHCP server, set your PC to obtain an IP address automatically from the DHCP server. And so it goes on through step after step after step using multiple, meaningless, multi-letter acronyms, and after about 3 hours we were no better off, so I disconnected the bloody switch, stuck the Ethernet cable back into the computer that I use every week, tried to restart it tonight on the live stream, and found that, yes, I could transmit a live stream in my OCP software, which I'm doing at the moment, but I had no monitoring back from the internet. I'm now of the opinion that I should follow the adage, if it ain't broke, don't touch it. And so consequently I think that this little switch, plus the idea of running Zoom on that computer and live stream here, may have knobs on it. VK3DLW and the group, I mean, this is an admission of my own lack of computer expertise, but I honestly feel that if a commercial company advertises something as plug and play, you should be able to plug and bloody well play it. VK3DLW and the group VK3AML.
VK3AML, VK3DLW, that's all pretty confusing, Chris, because a switch, to my way of thinking, is purely a layer 2 Ethernet device which does not have an IP address. So, whereas a router which is aware of the IP layer, layer 3, does have an IP address. So a thing that needs an IP address to me is not just a switch. So I don't know. I'm confused by all that. That's really weird. I've got numerous switches installed around here, and if they're true switches, layer 2 devices, they don't need an IP address. They have a MAC address, which is their Ethernet address, and that's it. And that is hardwired in. So I don't understand that at all. It's really strange. Anyway, thanks for tonight's transmission. That was really interesting. As Peter says, we did work a bit of DX, or I did work a bit of DX. And just on your subject of signal reports on 20 metres, the most amusing conversation I heard was a guy who couldn't get the other guy's call sign, but he gave him 5 and 3. I don't know how that happens either, anyway. But look, from the point of view of tonight's content, the most interesting thing to me was for about 3 years I was involved in the project to upgrade the automation of the directories assistance system in Telstra. It was actually owned by Census at the time, and the whole idea was to take the automation rate from about 18%, and I think it ended up at about 48% in the end. My main involvement was to take the directories database and hand it over to the company that was doing the work, which was Nuance, who I believe produced the Dragon product, which is supposed to be one of the better speech recognition engines, I believe. But they had the job of, recognising all the phonemes of various accents, people from all over the place, and diversity, and translating that into a textual lookup of the database, which was really interesting work, because they would work to optimise it as well. So when an automation failed, the data would be completely anonymised, but the actual phraseology that had been used would be recorded, and then when the agent had resolved the request, the actual outcome of that would be compared to further optimise the database. Nuance would take that away, and they would come back and produce the next build of the voice recognition database, and so it was interesting work. People either loved it or hated it. There was mixed feelings about the fact that it was decided to move from a female voice to a male voice for the text-to-speech. It must be an incredibly tedious process for the person whose voice it is to actually record stuff, because it would be in their voice, but for words that were most commonly recorded or most commonly used, they would be actually recorded as those words. So they just sat there and recorded all these commonly recorded words. And people who hated it and abused it, well, they should be aware that what they say is actually repeated to the agent. So quite often, if your automation call fails on Directories Assistance, and not that many people call it anymore, first thing the agent will say, "Oh, you're after Smith in Selby." Now that should tell them that what they said to the automation database was actually repeated to the agent before they got online. So if they abuse them, that's what the agent hears. Anyway, so there are all sorts of interesting oddities about it. Anyway, probably enough for this over. VK3AML in the group, VK3DLW.
I honestly can't remember directory assistance being automated. It must have been only a short time. I think they terminated directory assistance, as far as I'm aware, many years ago. And now you have to look it up on white pages on internet, or at least most people do. And I think they've also stopped printing this telephone directory, unless I'm mistaken. Some years ago I had to go to the State Library, and looking up people's addresses from years gone by, one of the options was to look into the State Library and get them to bring out their archival copy of the phone book from the State Library's collection. But interestingly, they only collected the phone book, as I understand it, at the State Library once every 5 years or so. The oldest version of the Melbourne phone book that I have here, incidentally, is the 1915 edition, which is about 3/4 of a centimetre thick and about demi-octavo size. So it's tiny number of subscribers during the First World War compared to what there were in the 1970s and 80s, when the phone book was 2 inches thick or 3 inches thick and went to 2 volumes. But it makes fascinating reading. The number of motor mechanics was almost equal to the number of farriers putting shoes on horses in 1915, and they're all in the phone book. And interesting about the voice recognition. Sometimes I wonder if some of these systems designed to aggravate, designed to put people off phoning. Interesting getting the other side on it, Graham. Okay, so it's back around to Peter, and note the Heathcote, you got a -8 one night. Oh, brother. I don't think I would have liked that in a tent, particularly. I'd much rather be home under 3 doonas with my wife lying next to me as a little hot water bottle, or rather larger than a normal hot water bottle, but nice to cuddle into. That's one of the good things about winter, if you have a wife, the snuggle effect. And Namibia, V51MA, had a long conversation with a chap from Namibia in, of all places, Haast in New Zealand. There was the guy running the local motel there, had gone from a desert coast at Namibia, where he ran a tourist venue, to running one of the motels at Haast, which is as far south on the west coast of the South Island as you can go without hitting bush tracks, really. Very wet, very cold, very green. Talk about going from one extreme to another, but I think Namibia is one of the driest places on the face of God's earth. What little resource it has comes from the sea, which is very fertile, but the land itself is pretty bloody awful. Peter, VK3ACZ to take, VK3 Alpha Mike Lima.
VK3AML in the group, VK3ACZ. Chris, it was -1.8. Of course, you're absolutely right. It felt like -8. But the good thing is, if you've got a good sleeping bag, which both Sandra and I did have, the cuddle effect wasn't necessary or wasn't possible because we had separate bags. But if you're toasty warm, you're fine. The hard part is because I know I've been in outback New South Wales when the temperature was very low. And it's awful trying to sleep if you're cold. You just can't do it. Jim spent most of his time huddled in front of the fire. I think the campfire was a very popular place, but a lot of fun was had. Anyway, Dave, to answer your query, yes, it was a centre-loaded diamond that I was using. It's a 2-metre long whip thereabouts with the magnetic base on the car. Completely surprised that it was so good. Mind you, 5-1's not a brilliant report, but it's the first number that's so important. And Graham, yes, I've heard people give 5-3s and even way more than that, but still not be able to pull the call sign out. It's kind of funny in a way. I don't know what it is. Maybe people don't want to hurt your feelings or something, or think they're giving you a pat on the back. And Dave, I did hear your counterpart, you talked about going back home to the old country. I heard your counterpart, Golf 6 Echo Charlie Golf, during the week. The grey line on 40 metres has been going very well. You can set your clock by it almost at 4:30 in the afternoons. England seems to come in fairly well. I worked a Welsh station who was telling me a bit about what the high temperatures were like. He didn't describe the 40 that apparently has been reported about London, but I know we mentioned it last week. I found it difficult being in London when it was 30 degrees or 28 degrees with the tropical humidity, so I can't imagine what 40 is like. I know in those pokey little subway trains there's no air conditioning. There's just nowhere to escape from the heat at all in London, so I really pity them there. Now, what was the other thing? That's pretty much all for this. Oh, that's right. I wanted to ask you, Chris, because you'd announced previously, and I'd forgotten, just so looking forward to your test transmission, of course, you'd said that you wouldn't be on this week. Have the number of viewers been commensurate with that, or have you got your usual number of people checking in? Just wondering, VK3AML in the group, VK3ACZ.
Yeah, Peter, the numbers are down a bit. There are 16 watching now. It's only hit, I think, 17 or 18 at the peak. But as Harb in Sydney said, one of the problems is that for many people this is too far away from conventional ham radio at the present few get involved with digital. Analog is more user-friendly at the moment. It probably is very much. But as software-defined radio is becoming the rule rather than the exception, and as digital is increasing in usage, initially on systems like D-Star, which I can take or leave, frankly, there are better ways of dealing with VHF communication. But on HF, where you've got selective fade, noise, static crashes, variable signal levels going up and down by 4S points, I really think that digital audio correctly applied with some really intelligent compression and through a decent modem, as 5DGR Dave Rowe suggests, has potentially great advantages, and this thing of neural networks providing a far better decoding system, far more natural. We could eventually hear broadcast quality speech being transmitted across the world on 20 metres. It's within reach, and software-defined receivers with their very flat IF are inherently better suited to multi-subcarrier, non-speech transmissions, digital transmissions. So I'm sure it's going to barrel on ahead over the next decade and probably become, when it gets really good and the audio quality is acceptable and the modems are optimised, which according to Dave on those lectures is nearly the case now, we're going to see that as the predominating medium, I think, and not before time. I'm just reading through some of the comments here. Jared Quinn up in Sydney is far more computer literate than I am, far more adept at adjusting things like TCP/IP and all of the getting into all of the acronyms. And it's a pity you're not in Melbourne, Jared. I'm really floundering on this getting two computers to talk to the one Ethernet cable, and that's the thing stopping me from using Zoom or Skype. I don't want to put too many things through one computer at one time that it can't handle. Although I've got a good quad-core computer, I just feel that I should probably run Zoom on the computer screen on my right, so that I can be seen and my respondents can be seen, and I can pipe in the audio from the separate computer with its separate sound card through the mixer and vary the level. Because the levels on Zoom, in my experience, they vary greatly from one microphone to another, from one headset to another, and from one user to another. Just looking down the comments here, Mark Harrison, trouble is you didn't have a 10-year-old to help configure your network. Isn't that the truth? If you can't work it out with computers, you ask a 14-year-old or somebody younger. And that's a great way of kicking your ego around, but it's a great way of sorting things out. Just looking down the list here. Jared is, by the way, VK3AML for those interested. And Ardran, one of my other correspondents on the text chat, says, I agree with that, Jared. Networks are easy to understand compared to RF magic. Well, having come up with RF since the 1960s, I find the opposite. I suppose it's a case of once you get into your 50s and 60s, your thought processes are a little more ossified, hardened than they were previously, and you have to get your head around it. But I acknowledge that this instruction manual to set up this switch is something I'll just have to get some help with. Chris VK3CJN from Lilydale has offered to come round on Monday to see if he can help at all with it setting up. He's used one himself, And if we can't get this one working, he apparently has a replacement that may work. Whichever way it goes, as long as I can get something going, I'll be happy by next week. And it will be very interesting, Dave, if I can get Zoom going in time to see if we can actually link you in from England, because the convenient thing, from your point of view, Dave, if you are going with a tablet or something similar, is that 9:30 p.m. when we start here is lunchtime in Britain, a very convenient time to watch. VK3CG and group, VK3AML.
Yeah, VK3AML and the group VK3CG. Yes, that's right. So, as I said, it's depending on what's happening on this sort of family front, I would thought that could work out very well indeed. Yes, and I mean, I think, and I spent a long time losing Zoom, and I certainly will have a device with me, because even though I'm on a sort of family visiting, a holiday type trip, I will be doing a little bit of writing and other things that will need to be done. And at one stage I've got to actually run some tutorials. I did explain to my mother that I might have to do one or two of those things, but actually, as you point out, in fact, it works out quite well, because even my early evening tutorials, which is what I tend to do here for particular students who are all in full-time work, which is the case for most of them, it means it's just nice and early in the morning, not too early. So that's rather nice. So I tend to run things at sort of 6:30 p.m. for people here, and so when they sort of finish work or get a gap to do some online stuff, and that's a comfortable 9:30 in the morning, which is rather nice. But yes, the temperatures, I mean, 30, I think it was just up into the sort of 40 point something or something in London, which is probably fairly typical for a city. London is a place that doesn't really get a lot of sort of airflow. I've been in London when it has been in the sort of 30s, and so I'm visiting, and it is very unpleasant. Part of the problem is that, as you rightly say, the underground doesn't really have air conditioning. It has sort of an airflow system which just gets hotter and hotter slowly. Of course, being deep down, of course, it is generally a bit cooler in summer and a bit warmer in winter. But the absence of air conditioning is a problem. Even the air conditioning that's there, it's not designed for temperatures, up in the high 30s, 40s. It's air conditioning systems that are designed for temperatures that are going to be making people slightly uncomfortable at 25 and 28 and things like that. And so when you hit it with 40, I mean, it just becomes it just fails usually. I remember once when we had some very poor air conditioners at work here, we had to go out to a hardware store and buy some garden sprinklers to put water on the cooling elements on the roof, because it just could not cope and could not evaporate the stuff fast enough. So it is interesting when it happens like that. Yeah, I was reading all those chat things in relation to your switch or router, whichever it is. So if it's supposed to be a switch, as people were saying, I think that's right. It shouldn't have any real problems. But if it's being set up as a router, then it gets a bit more complicated. Of course, there is the RF type approach to this, and I have some sympathy with your view, Chris, because I have the same sort of issue. RF seems a lot easier to me to understand than some of the computing terms. You could just get another reel of Ethernet. If you've got a spare port on your modem, just run the other computer on another Ethernet cable and pull it through. It's a bit expensive on the Ethernet cable. On the other hand, it avoids much of the setup issues. But there again, you may not have a spare port. That's the sort of hack it and see approach. But of course, the elegant network people will tell you that's completely unnecessary, and you just got to configure everything properly. Well, that's true if you can. Yes, so we're going back to the acoustic environment you were talking about. I absolutely agree. If you actually listen to recordings, and of course you have, studio versus various environments, and the difference is extraordinary. I listen to a particular call group that I like very much, which is called Voces 8, VOCES 8, and they're 8 voices essentially. It's a UK group, but they have sort of world renown. I think I mentioned them before, but you hear them sing a piece in different settings, and it's almost entirely different. And I think it's the way in which it's the rebound echo and coming back from so many different surfaces that helps blend a sound. And sometimes it can cause real confusion, particularly when you're singing in a very, very large space, where the sound that's coming to you from the person standing next to you or around you is, of course, a completely time difference from the sound that's coming back 50 metres away from the far end of a cathedral or something like that. And then the conductor's 20 metres away or 10 metres away or whatever it might be, and is beating to what they are hearing, and that can cause quite a lot of confusion, and why conductors, sort of say, look at me, don't look at me for rhythm and things like that. And they're quite right, of course, if you're trying to bring the whole thing together. But it can be very, very confusing. But sometimes with some things like multiple voices, it helps create the blend, which I think is quite wonderful if it's in the right environment. And worth listening to, because that particular group pays a great deal of attention to their audio recordings. And recently with COVID, I think a lot of people have started to really take this sort of seriously and produce a lot more stuff on YouTube and so on than perhaps they had in the past. And as a result, there's both good and bad coming out of that. But some groups have played a lot of attention to really trying to do decent recordings and put them up because they haven't been able to perform for audiences and things like that. So it's really quite an encouraging sign. As for digital notes, I mean, I've certainly had a few D-Star chats on Simplex as well on VHF and things, and look, it's a different sound, and it's certainly not as pleasant as a good quality FM signal or even a quality side, but it's really hard to pick that. It's almost got that sort of harsh beginning of the word, as if the early sort of as you make the first sound, it sort of starts that decryption process, and it sort of almost sort of there's a bit of, I suppose, sort of neural networks do sort of a little bit of learning and correct it as it goes, but it does that so frequently, it just gives you this very strange initial sound to the word. And after that, I suspect your brain fills in a lot of the gaps. Anyway, back to you. VK3AML on the group, VK3ECG.
VK3CG and group VK3AML. I'll just see if anybody would like to join us. VK3AML. Anybody else like to join us for the chat? VK3 Alpha Mike Lima standing by. Nope, nothing heard. Just 3 of us, 4 of us. Yeah. The underground and the airflow in 40C in London, I believe the trouble is that when London gets hot, it also gets very humid. And for people who've never experienced 40 degrees C before, I can imagine that after climatisation to Britain's climate, particularly in winter, 40C would be killing, almost literally for old people over there. And houses not designed for the temperatures, it's houses designed to capture heat rather than reject it. Yeah, that would be really difficult. I mean, it's hard enough in Australia when we hit 40C, but at least it's usually dry heat. As to why I don't run another Ethernet cable, yes, my modem, which is at the front of the house facing the street, and this room, which is at the absolute back of the house, this wall in front of me here behind the screen is the back wall of the house. The trouble is that the existing Ethernet cable goes 25 metres through a fairly inaccessible roof cavity, which I had to hire a very small, you'll laugh, a very small handyman to run for me through the roof cavity. He's only about 5 foot tall, very slim, and can get through in between the structural members inside the roof cavity, and was able to just lay that cable in a good afternoon's work that cost us several $100s. So I don't want to run another 25 metre cable from our modem. As for RF, we're just on the verge of not being able to get the RF from the modem in the other room, so really I have to do it by this switching system, this very complex smart switcher, which, in spite of the fact of them saying plug and play, it's plug and frustrate. That's what it is. I was trying, for instance, this afternoon to listen to Dave, VK3ASC, his shortwave transmitter, which he calls Shortwave Australia, on 4835 kilohertz. There it is, a plug. Sorry, Dave. But he's putting out some very interesting programming made by himself, by Steve 3SL, Steve Langley, who's a qualified musician, music teacher and cellist, and finally has a legal outlet for his documentary material through Dave's shortwave transmitter, and that's going extremely well. So I wanted to get 4835 going via WebSDR on this, on my right, this computer, and maybe stream it while I was talking about it through the existing webcam and the original computer. But no, it was not to be. It was going to frustrate me. Either that would work, that computer number 2 would work with the WebSDR, or computer number 1 would work with the live streaming, but not bloody both together. So hopefully 3CJN, who has a bit more experience in setting up computer systems than I, will come up with some ideas tomorrow, or maybe we'll just drop the thing in the bin and forget about it and just persist with the system the way it goes. But I really would like, particularly from the point of view of Europeans, where it's a convenient time to look in and to give some feedback, I really would like to get some voice over IP system going simultaneously with the live streaming, and I really feel it would be better with the second computer and a second sound card that I can separately control. So that's the situation there. Running a second Ethernet cable, yes, it could be done, but it'd cost us hundreds of dollars an afternoon with a handyman to run the cable through, and it would involve a run of something like 25 or 30 metres of Ethernet cable. Not easy. Now, over to Graham, and that business of not being able to understand the call sign repeated and then calling it 5 and 3. I really doubt whether the average person on a ham radio knows what the Q code is all about, and what readability 5 means and what readability 3 means. And on most of the WSJT programs, it's VKXXX59, irrespective of how good or bad the signal is, which I think is dishonest. VK3DLW and group, VK3AML.
VK3AML, VK3DLW. Yeah, Roger. Yeah, Chris, on your networking thing, I have to understand what problem you're trying to solve that actually needs any sort of layer 3 device. I mean, I run one Ethernet cable down here from the front of the house where our modem is, and I can run everything I need to off that with the aid of 2 layer 2 switches, which you just plug in and they just work. I've got my 7700, which has got an IP server inside it that runs it. I've got a computer that runs it. I've got a wireless point down here that all runs off ports off the 2 switches in the shack. So I'd have to understand the problem you're trying to solve that actually warrants the need for any sort of layer 3 device that needs an IP address. Anyhow, I'm sure your help will sort it out. But yeah, just on the question of the demise of directory's assistance, it's a bit like Voltaire said, reports of my death are accurate but premature because...
Welcome to Telstra Directory Assistance. Please note, this call may cause
So, and the reason it still exists as much as anything is that it's still a condition of Telstra's carrier license to provide voice directories assistance. And I would say that must still be, that was certainly the case 3 years ago, and I'd say it must still be, because I tell you what, the moment it's not, it will no longer exist. But it certainly does at the moment. And part of the reason it exists is because of a lobby group of, unfortunately, people probably about our age, Chris, who are hardened adherents to wanting it, and people who are vision impaired as well, who also can't look up a directory or use a computer very well. So it is probably for them as much as anything else. And there is actually a number of that folks who have who are disadvantaged or impaired in some way can also number. There is a set of agents who handle their queries as well, but they have a specific number and they have to be registered to do that. And I don't know that's part of the carrier license condition, but that is a service that's still provided, and it's designed for folks who may have other impediments. Anyhow, so yeah, reports of his death are premature. The other interesting thing I thought was, as much as anything else, was about the influence of peer groups on accents, because I had a friend right through primary school and high school. It was really interesting in a way when I think about it, because he was the youngest of 10, and it was an Anglo-Indian family. His mother was English, his father was Indian, and the oldest of his family was born in 1928 through to when he was born in 1952. So what I really had there, without knowing it, I guess, when I think about it, was a set of a group of folks who had progressively more Australian accents, and Peter had no trace of an Indian accent. Of course, as you went back through up the scale of his older brothers and sisters, they had increasingly stronger, what would be considered, I guess, Indian accents. So that was an interesting active experiment. And my daughter, when we visited her in Ireland, she went to the Irish National Stud, that's right, to work for a while. She had a German friend whose name was Nina, appropriately enough, and she had learnt all her English in Ireland, and she had an Irish accent. So that was the influence of, I guess, her peer group on her accent. So all that I found, some of the most interesting content in tonight's presentation. VK3AML in the group, VK3DLW.
Yes, and I wonder whether codecs will adequately take account of that. If a codec has been designed for people with Australian or British accents, will it cope with people with thick Irish accents? Will it cope with people with Italian accents, etc.? Interesting question. I wasn't aware that directory assistance was still there, perhaps because our telephone account is Optus, and I don't think the Telstra inquiry number is available from an Optus phone, or at least I have an idea there's some problem, some block that way. In terms of accents, one thing I could run, because, I have that background with sound and film archives quite a bit. One of the most interesting collections of recordings in terms of speech and accents that I've heard of recent times has re-emerged from an archive in Berlin. There was an institute in Berlin, a speech institute, back at the start of the 20th century, and there are a number of PhDs there who were interested in recording, literally recording on sound recording media, disc or cylinder, the accents of different parts of, let's say, the British Isles. Now, where do you record people from different parts of the British Isles during the First World War? The answer is a prisoner of war camp. So there is a collection of some hundreds, it could run into thousands of test pressings held still by this German Speech Institute of characteristic British accents spoken by prisoners of war in 1916 on disc, shellac discs, 78 RPM, and many, I think most have been digitised and placed on internet. And the interesting thing is there was a BBC documentary about 10 years ago tracing the relatives, frequently grandchildren or great-grandchildren of the people on those discs, and playing them recordings of their antecedents. Some of them were old enough to remember those people alive, and the accents, particularly regional accents in Britain, have changed markedly over the last 100 years because of the advent of something as simple as a motor car. People didn't move around very much in the 19th century, no more than a suburb or two, or if they did move, they usually emigrated to America, to Canada, to Australia. So there were a tremendous number and a richness of cultural and speech heritage around the British Isles turn of last century that no longer exists, except on those records. So that, you've given me the idea for what could be an interesting scientific audio exercise for a future week. So I'll hand it round to Peter. It's now 9 minutes past 12. We probably should start to have our final go-round. Very nice to have you all pop up on a week that I officially announced I wouldn't be here. But what killed the social event that would have taken me and Prue away was COVID. 3 of our relatives came down with the Omicron version. And at 68 years old, my wife and I didn't want to be put in danger, although we've all been quadruple jabbed. VK3ACZ and group VK3AML.
VK3AML and the group VK3ACZ. Well, I was quadruple jabbed, but both of us were here, but it still didn't stop the thing taking effect. There you go. Just a couple of things. I'll make it quick to tie my ribbon for tonight. Graham's signal. I spoke with him about this when we were up at radio camp with Sherbrooke. There's 2,000 feet of dirt between him and I. There's the whole Ferny Creek, One Tree Hill pile of dirt, and yet I had to go into the house to grab a drink and took a little handheld with me, and his signal came in full quietening even with the handheld as I rummaged around the kitchens. There you go, all pretty good. D-Star and C4FM, the Yaesu system fusion, the 2 forms of digital that I've heard. Well, I've played around, being a Yaesu fanboy, played around with a little bit of Yaesu fusion. It doesn't excite me. It really doesn't. There's just something about doing battle with the ionosphere, the static crashes, the QS Baker and all the QR Mary from stations 1.5 kilohertz away and all that stuff that makes it enticing for some silly reason, go figure. But Dumbstar, as 1 or 2 people I know refer to it, is definitely an inferior sound to my calibrated eardrum. Your mileage might vary, your opinion might be totally different, but that's just my 2 cents and all of that.
Mine too.
I'll stick with HF for as long as I can. But anyway, thank you again, Chris. It would have been a pleasant surprise if I'd known that you weren't going to broadcast tonight. In fact, I wouldn't have. I wouldn't have turned on. Got the YouTube up had I remembered, so I'm glad I didn't. There you go. Forgetfulness has other advantages than meeting new people all the time. Cheers. Look forward to next week, or look forward to the next test transmission. Safe, everybody. Good night to Graham. Good night to Dave and yourself. And always appreciate what you do on a Saturday night, Chris, and there's obviously a lot of work during the week and a lot of thought and a lot of planning goes into it, and I don't know how you find all the stuff. It's pretty good. Anyway, you're appreciated, and I'll leave you with that. 7-3, VK3AML in the group, VK3ACZ, listening through to the end.
Okay, Peter, please give our regards to Sandra. Very nice when we get together. We'll have to do it again very shortly. The suggestion has been made by Tom, 3FTOM, that we all head up Donna Buang, which would be very interesting particularly interesting from a VHF point of view, secondarily interesting from an HF point of view. It is so far away from sources of noise for HF that it has that attraction, but for VHF you're up 1,200 metres. The horizon is a great distance away, and being able to launch into temperature inversions can be even further away on the horizon. So the chances of getting through to Tasmania, repeaters particularly from top of Donna Buang lookout towers, you're virtually assured of getting through whether there are conditions across Bass Strait or not. I'm looking at the discussions on the text chat next to the video, and they're talking about my PCs being configured with the same IP number on both machines. It would really require somebody with a great deal more computer expertise than I to manipulate that, and if a different modem is necessary, we'll certainly try that, and a friend of mine's bringing over a simpler one. This TP-Link may not have been the best one to use. It requires its own 5-volt power supply. There are traffic progress lights on each of the ports that are flashing away. It's still connected through to the second computer, but not to the one I'm on. And I did notice that my existing computer, once that port was on, was streaming much less quickly. I would have expected the bandwidth to be divided between the two machines, but not to be less than 50% in both cases. FTJS, it definitely is on, just something is wrongly configured, and my friend who came this afternoon didn't seem to know how to set it up. I can't set it up. CJN will be the next person to try. If he can't set it up, we'll start from square one again. And if I am absolutely forced, I will find the handyman again, the little bloke, to run another 25-metre cable through all the zigs and zags inside our roof back to the modem again for a second cable, but that will cost hundreds and hundreds of dollars, and appointments and time, and give me a break. So it's round to you, Dave, VK3CG. And as I say, I would have expected this thing of dividing an Ethernet cable between two computers to be so simple, and it has proven to be a pain in the arse. VK3CG and group, VK3AML.
Yeah, VK3AML in the group, VK3CG. Yes, I'm sorry about the suggestion of the other Ethernet cable. I'm just trying to get away from the sophistication of managing networks towards the dumb solution. But sometimes the dumb solution is a bit too dumb. Of course, you could be really brave and connect two Ethernet cables to the other Ethernet cable and try and see if you can pull the whole lot through without having one again go on the roof. But I daren't even suggest that on the grounds it will probably part way somewhere along the roof space, and then you'll have no internet access in the shack at all, and that would be even worse. But there we are. Yes, I'm with you on that. The COVID 4 jabs issue is doesn't stop you getting COVID, but hopefully makes the illness not too bad. I had a couple of friends who've had 4 jabs and have had COVID within twice within the period of 6 weeks. So if you're in a high-risk sort of situation, then that is entirely feasible, unfortunately. But fortunately, that is not the experience of the vast majority of people. Thank goodness for that. Yes, I'm just thinking about the peer groups and accents and the comments that you were making, Graham, also about Dragon and so on. I've used Dragon quite a lot, and a good microphone is essential in my view for Dragon to work effectively. I was very annoyed because I'm a bit of although I use a PC in the shack, I'm really more of a Mac user for sort of day-to-day working activities, and unfortunately Dragon no longer supports Mac OS as an operating system, which was a great shame because I had it all set up, and although I have actually at varying times had Windows on my Mac through Parallels and a few other things, and that has worked with Dragon. It's a little bit slower and not as quite as responsive, but a thing with Dragon I find is that a lot of people find it very difficult to use, and I think it depends on how used you are to dictation, because I used to do lots and lots of reports, and most of those reports were originally dictated onto dictaphones with little mini tapes in them and things like that. Moving to using Dragon wasn't too bad for me because I simply was already used to thinking that way in producing text, and so Dragon worked quite well. And I mean, I had some very early versions of Dragon and upgraded over the years, and the sort of improvements were just astronomical actually, until the current versions, where even the training levels you need to do are really quite low comparatively now to what you had to do years ago on the earlier versions of it. Yes, it makes mistakes and so on, but I find I finish at home to edit lots and lots of text anyway, when I'm sort of rethinking about it and re-editing, and I find it easy to do that on keyboard. I've seen people do it on Dragon, but I have to say I use it to get text down, and then I use keyboard and so on to do the sort of editing I really need to do to make it readable. So that's how I've used it. But accents are really fascinating. I found I would not use the Australian accent one. Sometimes I'd leave it on the UK one. Sometimes I'd actually go to the US one. It was a bit easier. It's very odd, actually, what sort of what accent it seems to want. But I think you're absolutely right, Chris. The way accents have changed has been dramatic, and I recognise that in my lifetime. Sort of when I was in North Norfolk as a child, and the people that were around us really had no transport. I mean, it was, the bus came once a day. They visited relatives in the next village town, perhaps twice a year. And most people got around locally on bicycles and things like that. And I'm talking about the sort of, early 60s and things like that. And as soon as cars came, the accent started to change. And it was really very interesting that spread in connection and communication, and that also goes for social life issues, different the wider access to radio. I mean, in the early days, of course, a lot of it was just BBC broadcast effectively, and they had their own unique accent. So I suppose that was also a factor in the whole thing. Anyway, yes, from the temperature point of view, we had -2 degrees in the morning twice here this week. I think Monday and Tuesday, and deep, thick frosts, which I have taken some photographs of, since it's relatively unusual here, but nothing like our UK experiences, of course. But thank you very much for a fascinating broadcast tonight. I really enjoyed that, and it's sort of tempting to start looking at those things. I could certainly download that sort of software and have a go, perhaps at HF at some stage, but not for a month or so. But certainly a great deal of fun, and would be interesting to have a try at some point. If you do get the Zoom thing running, and if you post a link on your Facebook page or whatever for the particular session and create a Zoom meeting, a public meeting, the only thing is that with Zoom, if you're using Zoom, I think it's limited to 40 minutes unless you purchase a Zoom subscription. So if something is running more than 40 minutes, you may not have that. But for a talkback aspect of it, then that should obviously be a little bit easier. So with that in mind, I'll say good night, everyone, and I probably won't be on next week. I think what happened, Chris, was I assumed you weren't going to be on this week, and therefore I wouldn't be coming on again. And but as you were on, I hadn't gone yet. So there we are. That's, I think, what must have happened. Yes, a trip to Donabang will be quite interesting at some stage. I've been up there and taken some interesting sort of photographs and things, but I didn't take radio at the time. But it would be fun to do that at some stage. All the best, and have a great few weeks, and hopefully we'll see you on at least online, if nothing else. VK3 ECG now from Theo. Good night, everyone. Nice to chat again with you, Peter and Graham. Cheers, then. Bye.
Thanks a lot for coming on, Dave. Always a pleasure. Now, in response to one of the questions on the on the text chat beside the stream, who thought that this switcher was limited to 100 megabytes, it's not. I'll just hold it up there, see if I can get this into focus. It should, yeah. There it is. The green light is showing on it, and that's 1 gigabyte per second. So it is quite a fast switcher. There's no trouble with that. And as you see, 5 years warranty to 23rd July 2027 from today. No, that was yesterday now, because we're now 20 minutes past midnight. But yeah, I'm sure Chris CJN will have some idea of maybe what's going on with this TCP/IP and subnets rubbish, but it's something that's beyond me to set up. I'm not sufficiently au fait with the networking aspect of computers to know very much about that. Audio, I'm much better. Now, what did I take notes on here? Oh, the accents and the fact that they were changing. One of the collections of wax cylinders that I had to transfer in the old days to tape rather than to digital was a collection of wax cylinders recordings, audio, recorded by the composer, the Australian composer Percy Grainger, at the turn of last century. Between 1906 and 1909, he used to visit what they called workhouses around industrial areas of rural Britain, recording folk songs from people who were at that stage in their 70s and 80s, so that they were born in the 1820s and 1830s. And that's going back so far that roads in the first half of the 19th century were fairly near to impassable over long distances, and people didn't generally stray more than about 20 or 30 miles from their point of origin. So the accents were marked, and regional differences in folk music style were also incredibly marked. And I remember reading one of Grainger's papers written at the time saying, we're doing all of this folk song and dance collecting now because in 20 or 30 years' time, when the motor car becomes general, these regional cultural differences will probably disappear, and I think they generally have during the 20th century. We have some regional differences in Australia, but Australia is so multicultural, it tends to be an amalgam of all sorts of things. Whereas in Britain, in rural parts of Britain, there are families that have been in their region for hundreds of years. Even today, to some lesser extent. My people mostly came from Ireland, County Wicklow and and Limerick, but there was a section of our family that came from northern Cornwall, so probably originally they spoke in a West Country accent. Ooh-ar. I only say that if I get annoyed with people. So, Graham, it's up to you to tie the ribbons, and it's 27 minutes past 12, and 12:30 would be a pretty good time to wind up. VK3DLW, if you're still with us, Graham. Sorry, I'm raving. VK3AML.
Yeah, Roger, Chris, and good night to Dave and Peter there too. VK3AML, VK3DLW in the group. Yeah, no, it's well, one interesting experience I had, accent-wise, was I moved to Melbourne in 1991, and this would have been in 1998, and I was working with a Vietnamese engineer who was had immigrated to Australia, and he said to me one day, "You're from Adelaide," and I said, "Well, how do you know that?" He said, "Well, from your accent." So I don't know. I must have used a few of those particular, I think you might have said phonemes that sort of give it away, and my kids are always telling me off about calling, I'm trying to remember, by now it's got so confused I've forgotten which way around it is. But Lego and Lago apparently is a tell between South Australia and Victoria, so I'm told. And my kids, who were pretty well brought up here, they moved here when we did. They were all in primary school, and they are perpetually telling us off for pronouncing it the wrong way, whichever way that is. So there you go. Yeah, we used to post, when I was working in defence, we used to post a lot of engineers to the US, and they would always complain that within a week their kids came home with American accents, and I think they mainly did that because they actually wanted to be understood, because Americans don't get exposed to a lot of foreign accents, whereas we get exposed to a lot of American accents, so we're more familiar with them, far more familiar with them than they are with any accent that we produce. And I found that particularly in the South, when I've been there, I was in Jackson, Mississippi once, and yes, whereas in California you can be understood pretty well, in when you get into somewhere like Mississippi, you kind of have to modify your speech just so you can actually be understood. And I caught a taxi, a cab, I guess they'd say, from the Jackson airport to my hotel, and there were two African Americans in the front seat, and they were talking jive, and I had not the faintest idea what they were talking about, which must be a whole study in itself, I dare say. Anyway, good night, Chris. We'll see you, we'll hear you next week, and see you, I guess, on the feed. Thank you once again. I found it pretty interesting, indeed, as I usually do. VK3AML in the group, VK3DLW.
VK3DLW, VK3AML. Well, as this week we kept it fairly technical, and in some cases going fairly deeply into computer science, I'll try to make it a little bit lighter next week by doing something archival and historical and easy to assimilate, much more than today. I only comment on certain words being difficult to understand. My wife spent quite a bit of time in California with her brother, who was lecturing at Berkeley up to about 10 years ago. I stayed with Terry over 2006 when I went over there in San Francisco. And my wife remembers ordering a drink at a bar, which any Australian would understand. She asked for a glass of vermouth, V-E-R-M-O-U-T-H, vermouth. And the bar guy says, "What? I'd like a glass of vermouth, no ice, please." "What's vermouth? Vermouth?" Do you mean VRMMOUTH? No, VERMOUH. He said, oh, vermouth. And it's lack of understanding on that level, even in California. I can't imagine how it would be in Mississippi or Louisiana, where they have that influence from the French and thick southern accents, particularly the difference between Afro-American and white American. Okay, it looks like we've come to the end of the line for this week, and this has been thrown together very much with the help of David Rowe, VK5DGR, from whom I sought and achieved his blessing for the usage of his lecture material. I can only hope that it concentrates a bit more attention on the progress that's being made with speech codecs and modems for HF communication, particularly when you think that they're being integrated into certain types of software-defined receivers such as the Flex radio. It seems that the industry is starting to take notice of these modes and make account of them. And for the next 10 years, I think we're going to see a drift, as David Rowe said, towards the use of software-defined transceivers, where the improvements will largely be in software rather than hardware, and the developments in modulation and modes will largely be in software rather than hardware as well. So it's an interesting introduction to that whole era that we're starting to go through. I look to the future. Thank you very much to the people also who are on my text chat. I don't have a normal feedback system here. When the TCP/IP addresses started to get screwed about this afternoon when we put this switcher in, I've screwed up something with regard to monitoring off the stream, so I've actually dialed into the stream as just another user. Jared says, I love both ends of the scale, Chris, the historical and the deeply technical, from radio astronomy last week to open source and radio merging this week. That's why you're back every week. Well, thank you for that, Jared. I'll take that as a great compliment. And Jared's saying there are a few very interesting accents emerging out of high schools around east and north in the last 5 years. The business of accents changing with time is an interesting one, because I can pick just from the voice, not from the quality of the voice, but from what they say and the accent. I can pick my 1960s generation of Australians from current teenagers. The intonations are totally different. If you go back, there are recordings of Australian speech going back, locally recorded, to 1926. I've got a recording, for example, of a bushfire heroine involved with Black Sunday 1926 that was recorded in Sydney. And her speech, her accent is so flat that you can tell it's a 1920s Australian accent. It was an accent that you no longer hear except in very, very old people in their 90s, for example, and particularly those who are not terribly well educated. The interesting thing is, with accent, you can usually pick the level of education behind the voice as well. So it's not just the words that you try to get, it's the intonation and the accent which tells you a lot about the person at the other end, which is one of the reasons that I greatly prefer sideband to CW. It immediately, the first words will tell you where a person's from, whether they're male or female, what their education is generally. There's a lot in the voice that's not just in the printed word. What else can I comment on before I close? Thanks for all those showing concern about the switching thing. It seems that I've run into an unnecessarily complex problem, which I would have expected to be solved much more simply. And I'm sure that I've got TP-Link that's well up to the business of getting the best possible speed out of the Ethernet cable that I've got. I'm just hoping that the combined speed of Zoom and Livestream is not sufficient to overload my cable. I may have to knock back the definition on the Livestream, for example, from 1080p to 720 or perhaps even lower if I run them all together. We will just have to suck it and see, as they say. One more thing that just came to mind while I was talking to Graham about accents. In the 60s, there was a characteristic language among primary school kids that I mixed with, and there were expressions used in the early 60s that I've never heard since. For instance, when a kid at primary school in 1962, let's say, that was when I was 8 years old, found something that was really great, really impressive, really enjoyable, we, because it was my generation of children at the time, would say, "Oh, that's massive, massive." And I haven't heard that word used in that way since leaving primary school in 1965. I wonder if anybody else of my age group remembers the usage of that word. Optus has Directories Assistance Service on 1223. Interesting, Graham. I don't know. I'll have to give that a try next time I get stuck for a number. I usually bumble my way through white pages on internet. VK5ZSH, thank you for being with us from South Australia. I see that even on this late hour we've got 13 still watching, which is not too bad. This has not been what I would call a very popular topic that a wide number of people in the ham community get excited by, so I'll have to select something a little bit more visually stimulating next week. But thank you all for being with us. Anyway, with that, I'll sign on 147.475 and take a final listen before closing. VK3AML listening on 147.475 before closing.
Chris, lock in Donna Buang with yourself and Tom. Sounds like a plan. Good night, Chris.
That would be very nice. I have a feeling that Chris CJN would be interested in that too, but in better weather than this. Tom tried to persuade me to go up there this last week, and I said, look, the last 300 metres of the road to the summit is closed. That would involve hauling a lot of gear a long way, probably through snow, at the very least through slush. And I would really like it to be September or October before we go. And thank you for that, Peter.
Cheers, Chris.
Okay, cheers. VK3AML now closing on 147.475, and hope to see people or hear people on this frequency next Saturday night, 9:30 p.m. as usual. VK3AML now clear. Good. And for the people on the stream, thank you also. Here's this, I'll pick it up and show you. Pull the inputs out of it if I can. There we are. This is the multi-way TP-Link that I've been talking about. I'll get this thing working tomorrow if it kills me, but this will be the means by which we'll be able to get more than one computer on in this shack viably on internet, and should be able to stream more effectively Zoom. Because if I ran Zoom as well as live streaming on this computer, the one that I've got live streaming on at the moment, it would mean that I would have OBS software running. I would also have the feedback from YouTube. I would also have the webcam software running and Zoom. And I've got a feeling that between the four of them, they'd have a bad effect on the system. The other thing is using one sound card for all that means that the mixing of the audio would be completely random. I'd rather have it running through another computer and feed the output of the audio through the mixer. So with that, just looking down the list of people on the text chat has been very active tonight. VK2WAY, Jared, always a pleasure. Terry, VK3FTJS, we'll speak on Facebook chat as well as direct across the bay to you. Harbs Electronics, VK Pirate, always lovely to see you chaps. Who else we've got here? Rolly from Auckland. Rolly comes on at about midnight Auckland time and persists with us until 2 or 3 a.m. He deserves a medal. Good on you, Rolly, and thank you so much for the usage of your Auckland Island material. I found it fascinating, the sub-Antarctic islands. I have a thing for islands, particularly in the south of New Zealand and Australia, as you might have noticed, and I will do a session on Stewart Island at some future date. Ardren, nice to see you. Who else have we got here? Mark Harrison. Forget the manual, look at a good YouTube video on the subject. Yes, I might see if the TP link has an associated YouTube clip, but I've got a feeling that there's something unique to this installation here that's causing me particular difficulty, because if they advertise this thing as plug and play, it should work with most systems. Why not here? I don't know. Who else have we got here? VK Pirate. Hi, Greg. No, I think we've covered everybody. VK5ZSH, lovely to see somebody from South Australia who has a half hour earlier than us. Incidentally, VK5ZSH, I've been using the Ironstone range web-based SDR to receive Dave 3ASE's shortwave broadcasts on 4835 this last week, and it works extremely well, as does that wonderful VK5ARG Kiwi SDR at Tarlee, north of Adelaide. That's probably the best and most sensitive SDR in the quietest place in Australia, and in fact SDRs is something that I will have to do a presentation on at some stage. We'll get it done. VK3 Alpha Mike Lima, now wishing everybody a very good night, and we'll catch you same bat time, same bat channel next week, 9:30 p.m. Saturday. All the best.